I don't know when the next one is. He's trying to organize, but I'm not entirely sure it's gonna work. But yeah. Oh, the judges.
Right. Hey, hi, good to see you.
Hey everyone, we can go ahead and get started now. So welcome to the semifinal, the Boston Semi-Final of the MIT Climate and Energy Prize. We're really excited to have you with us today. This is the second of our 3 semifinal events, and we're really happy to be at the Engine just down the road from our home base at MIT. The Climate and Energy Prize was founded in 2008, and it's been around now for 18 years as the largest and longest running student climate and energy prize. This year actually marks the largest applicant pool yet, with over 200 startups applying from top universities around the world. Our applicants came from over 50 different countries and 100 universities and are tackling the most pressing challenges across all sectors. Last week, we held the first of our semifinals in Singapore, and next week we will hold our last semifinal in Munich. These 3 events will determine which 12 of our 28 semifinalists will compete in our Boston Grand Final on April 17th, with the potential to win $100,000 in non-dilutive funding. But this prize is not only designed to reward the winner. We hope that by going through the competition, receiving feedback from our judges, benefiting from top-tier industry mentorship, and meeting your fellow co-founders, you have made significant progress advancing your companies. What makes this community so special isn't just that it's a group of smart-driven students, but also that we are all here for a collective reason. We care deeply about solving the immense and ever-growing climate and energy challenges. I hope you'll take the opportunity to meet our sponsors, judges, other startups, and attendees. One of the best things you can take out of this prize is the global community. And in fact, today you'll hear from 2 of our Climate and Energy Prize alumni in our founder panel, Macrocycle and Helix Carbon, which is a testament to the fact this community persists long beyond your participation in this year's prize. Today's semifinalists are tackling a diversity of issues across sectors, everything from packaging to waste disposal to geothermal to wildfires to data center efficiency and more. We're really excited to hear your pitches, and 4 of the 10 startups today will be moving on to our grand final, with the top startup taking home our $5,000 semifinal prize. We want to extend a sincere thank you to our longtime partner, The Engine, and particularly Emily Knight, Molly Papermaster, and Millie Mendoza for all of their hard work. As a home to so many tough tech companies and the relation to MIT, we couldn't imagine a more fitting place to bring together our founders. We also want to extend a big thank you to our 2026 sponsors. We are excited to have a mix of longtime returning sponsors and a few new partnerships as well. The prize would not be possible without your continued support. Lastly, thank you to our organizing team for all your hard work. This is a student prize run entirely by students doing this part-time. We appreciate everything that you all do. And our amazing judges. thank you for taking the time to provide our startups with your valuable feedback. We're excited to have a stellar panel of judges today. And now I will give you each a brief moment to go and introduce yourself. So maybe Jason, if we could start on your end.
Hi, I'm Jason Prappis. Sorry, my head is so big on the screen and in real life. I'm at the X Moonshot Factory, formerly Google X, on the Rapid Evaluator team. Really happy to be here today. So thanks.
I'm Ryan McPherson, partner over at Accelerate Ventures. It's a climate-focused investment firm based here in Boston.
Hi, everyone. I'm Richard. You're going to hear more from Emily about the engine. I work for Engine Ventures, which is the VC firm that kind of spun out of MIT that invest in tough tech. So very much in the building and happy to connect at any point.
I'm Dan Recht. I'm the managing director of Activate Boston. We're a nonprofit that funds and mentors scientists starting companies while taking no equity.
Great, thank you. A quick run of show today. So all of our startups will have 10 minutes to pitch, followed by 8 minutes of questions and answers from our judges. Kayla over here will be keeping time, so you can look to her if you want to see how much time you have left in your pitch, and she'll give a gentle reminder to the judges when we're done with Q&A. We have, to begin with, 3 startup pitches, followed by a keynote speech we're very excited about from Marianne Wu from Congruent Ventures, and then we'll take a short break, followed by 4 more pitches and lunch. And then lastly, we'll wrap up with our 3 pitches, and then have a founder panel, which will be featuring Helix Carbon, Sora Fuels, and Macrocycle. And then we'll be announcing the finalists at around 4 p.m. So without further ado, I'll hand the mic over to Emily Knight, the CEO of the Engine, who will give a few more remarks.
I'm always a little bit peering over the podium here. Good morning, everyone. It is great to see you. We are so excited to be the host here today for the Climate and Energy Prize. This is a really important partnership for us. The Engine is an incubator and accelerator that was spun out of MIT, literally designed so we could create more translation activity. This is the perfect partnership because this type of activity, prizes where we are nurturing startups and technologies out of academia and creating the community and the ecosystem around them. That is exactly what the Engine thinks about every day. We execute our mission through infrastructure, programs, and ecosystem. So ecosystem, what we're doing here today, all of you, the judges, thank you for your time. It is a really important part of this. To the investors and operators in the room, thank you for helping these companies step out of academia and think about all of the challenges they're going to need. And to all of the founders and students, this is a really important journey, one that we think about all the time. Highlighting that pathway is the most important thing for us, nurturing talent. This is a long and arduous pathway. It is not easy to start a tough tech company. What we know about tough tech is it takes a very long time, it takes a lot of resources, and it takes an ecosystem. You're going to need all of the people you will meet at programs like this along the way, the judges who are going to help you, the investors who are going to talk to you, and all of the people in the room in rooms like this along the way. So think deeply about making those connections today. Our journey thinking about lab to market, we've run a number of programs that are very akin to what we're doing here today. So again, this is very close to our heart. We're so happy to have the groups here today. Thanking all of the group, I also want to congratulate you on all of your numbers. It is very impressive, the number of people who, even in this environment, continue to start climate and energy technologies and companies. It is a very important thing to support founders. Again, I just want to acknowledge this is a big day. A lot of companies start in rooms like this, and to the founders, all of you who are pitching today, good luck. We are very supportive, and thank you again for all of you. We're so happy to have you here. I'm going to turn it back to May for the pitches.
Great. Well, without further ado, we're going to turn to the pitches. So Cosine, you all are up first. So you can come up and get ready, and I'll pull up your slides. And for all the startups who are here today, this is the clicker. You just click the green button to go forward and the red button to go back. And you can use this microphone if you would like to walk around, or you're welcome to stand here. 1 second, technical issues. There we go.
Testing, testing. Hi, everybody. We are Cosine, and we are building electrified, cost-effective, high-grade heat. Heavy industry accounts for 23% of annual global emissions. This includes petroleum refining, steel manufacturing, cement production, and chemicals processing. Now, heavy industry is hard to abate primarily for one reason, and that is that each of these processes require heat, and not just any type of heat, but high-grade heat. Within heavy industry, close to 3/4 of energy usage goes to heating alone. And today, that is done primarily through the combustion of coal, natural gas, and oil. Now, to replace this, for low to medium temperatures, anything below 400 degrees Celsius, the industry standard clean technology are heat pumps and resistance heaters. However, for anything high temperature or above 400 degrees Celsius, there's currently no dominant solution. That is where Cosine comes in. We aim to fill this technology gap. We are targeting the chemicals manufacturing and processing space because it is single-handedly the biggest consumer of industrial heat. Over 40% of industrial heat is used. That is equivalent to about a gigatons of CO2 emissions. So for Cosine, that is an opportunity to abate. If you look at heating in a chemicals industry today, it is primarily done through the delivery of steam or hot oil. In a hot oil system, you have hot oil pipes that are insulated, heat exchangers, heater tanks, expansion tanks, pump skids, exhaust stacks, not to mention all the natural gas piping that is required. If we electrify our system and electrify the heating, we can reduce our heater size or our reactor size to much more modular reactors because the temperatures are much more uniform. We can replace our entire heating skid with a solid state power electronic system. We can replace all our pipes with just cables. And this entire thing is fully digitally controlled. So we can reduce the capital infrastructure and cost by going electric, but also control and process intensify. Now, we don't have to look too far when it comes to electric heating technologies. In your kitchen, you have a toaster, which is a resistive heater. You have your microwave, which is a microwave generator. And if you're fancy, you have an induction stovetop, which is an induction heater. We argue that induction is the most scalable and translatable technology. But before we go into why, let's talk about how induction works really quickly. So induction composes of two components. The first is a coil, and the second is a susceptor, which is the thing that gets hot. You send in current to generate an alternating magnetic field, and that couples to the susceptor, generating currents inside the susceptor, and that is the source of your heat. Now, the physics dictate that this is a wireless and volumetrically heated process. So because of that, we can get much higher temperature operation, but also achieve much more uniform temperature profiles. Secondly, induction is scalable because there is already industrial precedence. The metallurgy industry uses megawatt level induction furnaces to melt scrap metal, which is a 1500 Celsius process. We are taking induction to the next level. So based on the research that we've done at Stanford, we have patented technology primarily in resonant susceptor heating. So just like you would push a child on a swing at its natural frequency to increase the energy of the system, a resonant susceptor has a natural frequency. And if you excite it at that natural frequency, you can get 99% power to heat efficiencies. Whereas in conventional cases, typically less than 90%. You achieve much more uniform temperature profiles. And the best thing about all this is there's really no special materials, just metal. So fabrication is incredibly simplified. Secondly, this unlocks the fact that you can pressurize your system because you couple less to the walls of your pressure vessel and more to the susceptor. And the chemistry or the chemicals industry really cares about pressures. Most chemistry happens at high pressures. And lastly, we've patented dynamic temperature control. So we can rapidly respond to disturbances, we can shape temperature profiles, and this makes us compatible with intermittent renewables. So what are we bringing to the table? Our value proposition is that we are building a fully integrated reactor powered by the power electronics. With our power electronics, we can achieve greater than 97% efficiencies using silicon carbide-based technology. And then with our reactor, we get things such as uniform temperature profile, high power to heat efficiency, faster ramp up. And ultimately, our value proposition is that we are specializing in the co-design of the power electronics and the reactor to bring forth new limits of process intensification. Things such as yield, selectivity, throughput can all be enhanced. We are targeting the specialty chemicals market because of several factors. The first, they are low technical risk because they don't require huge scales. They have high product value, and so the energy costs is less important, and they are willing to adopt immediately. Eventually, we want to scale up to the commodity chemical space, which has a market cap of about close to $2 trillion to allow us to grow and expand our business. So our business model is to form strategic partnerships with specialty and commodity chemicals, where we build customized reactors that are bespoke for their process and their chemistry. We are building both the power electronics and the reactor system, including the software, the auxiliary equipment, and the idea is that we sell that. And through secondary revenue, we can, by doing engineering services, customization fees, commissioning upgrades, we can earn a secondary revenue stream. So compared to other technologies in electrification, when it comes to microwave heating, plasma-based heating, and also resistive heating, we win across the board in terms of power electronics efficiency, power electronics complexity, the heating profile itself, and the temperature range, where we can get 97% or above electronics efficiency. We don't need super high frequencies to couple really well, and our heating profiles are volumetric, and lastly, we can achieve temperatures above 1,000 degrees Celsius. So our ultimate competition is not really electrified heating, it's actually fossil fuel incumbents. So compared to the heating oil system that I mentioned earlier, the selling price of these things are incredibly high. So these things cost above 100K, and because of that, the payback period is 7 to 8 years. Now we can reduce that by almost 3 times and reduce our payback period to less than 3 years. We offer the cheapest, the cleanest, and the most operator-friendly solution, and we can adapt to customers' needs. So we've done a ton of customer validation, and they've claimed that they love the fact that it's an electrically isolated architecture, so it's safe. They love the fact that it's a simple heating system. You just need one coil to heat the entire bulk, and the fact that they don't have to deal with heating tape, which resistive heaters typically use. So in terms of decarbonization, this is what our potential is. If a specialty chemical plant were to operate with 100 chemical reactors, that over its lifetime of 20 years can achieve 1.75 terawatt hours of energy. And assuming that this is powered by renewable energy, our ceiling is 350 kilotons of CO2 avoided. You scale that up to 10 plants, and you can get to 3.5 million tons, which is about over 700,000 cars per year. So what have we done so far? We've filed 4 patents. We've demonstrated things at a lab scale. We've done over 140 stakeholder interviews. We've secured an NSF SBIR phase 1, which is about 300K. And we've signed our NDA with our first customer to build a sub-pilot process for validation. With the help of MIT Climate and Energy Prize, we plan to expand our team, build, design, and de-risk a sub-pilot prototype, where we will take that prototype, bring it to a test facility to validate it, and then hopefully in year 3 deploy it across our first customer, and then eventually scale it up to commodity chemicals and potentially other markets. We are a team of 3 electrical engineers from Stanford. My name is Calvin. I am the CEO of Cosine, and I am currently wrapping up my PhD in power electronics for thermochemical reactors. My co-founder, Connor, who's on the Zoom call, is doing his PhD in reactor engineering and multi-physics design. We are advised by Professor Jonathan Fan, and we are ultimately very, very excited to commit to rebuilding this industry. So if you're interested in joining us, let's rebuild industrial heat together. Thank you very much.
Thanks for the presentation, Calvin. Do you see this as a retrofit or for new builds only?
So yeah, great question. For, I guess, Connor, if you can't hear, this is primarily a new build technology, because as you imagine, like replacing all the heating systems of a chemical plant is just going to be incredibly difficult to do. And so just to reveal a little bit of details about our first customer, they're incredibly ready to expand. Typically, these chemical plants are like looking towards systems that are more modular, more efficient, much more clean, and they are built based off of like a renewable energy source. So they actually don't care about energy costs at all. So this is really to target like expansion. Yeah.
Okay, thank you.
Great job. Really appreciate the voiceover of the company. Can you tell us a little bit about just the levelized cost of heat for the customers that you're providing as you look forward, especially compared to what they're doing now with natural gas, and in the context of, you know, potentially other customers where they do care about the cost of electricity?
Yeah. So for the case of, it depends on the process fundamentally. The specialty chemicals case is unique because the value of the product is so high usually. So for example, we're like making lubricants for additives where you can get you can assume even like California prices of electricity, but we're assuming Texas, for example, where essentially because the product value is so high, then you can kind of override all the energy costs. Yeah, when it comes to like levelized cost, if we're like assuming maybe like 10-year of lifetime, like we can win across the board. Yeah.
I'm curious what you're carrying in terms of electricity costs in your own.
Like the assumptions?
Yeah, what sort of assumptions are you pulling in?
6 cents per kilowatt hour. We're assuming a utilization rate of like 70%. So assuming that these companies don't operate 24/7, because in commodity world, like you're operating 24/7, but in especially chemical waste or space, it's like 5 days a week. Yeah.
Great presentation. One question. Do you anticipate that access to power could slow down the adoption of the solution? Because really power availability these days is one of the biggest challenges. So what would be the power consumption increase versus a traditional solution of the whole plant?
Sorry, can you repeat that question?
Yeah, sure. I'm just wondering, what is the, do you anticipate that access to power could be a challenge? Because you would increase the need of power, which is one of the key resources.
Yeah, so when it comes to like access to power, it fundamentally comes down to whether or not a chemical plant has, you know, the grid connection or whether or not they want to expand to renewable. For a specialty chemicals case, like there's not that much power that necessarily needs to go. It's not like at the gigawatt scale. If you're talking the commodity chemical space, then you sort of need to build sort of your own substations and figure out, you know, with your operator, how do you expand to these larger scale power consumption cases. But in specialty chemicals cases, like they're already using electric tech, like power for other systems. Even like a lot of the customers that we've talked to, it's been like they do hot oil heating, but electric, but it's not super efficient, right? There's a lot of heat loss everywhere. They have to deliver that steam or that hot oil. It goes through a ton of piping. So it's more that these cases are just not as, or the beachhead for us is not necessarily the most difficult to get into from an electric power standpoint. Yeah.
No, thanks so much for the presentation. It was great. I guess building off some of the earlier questions, I want to know how bespoke your project has to be per specialty chemicals. I mean, it's a very fragmented industry on the whole. I mean, I think you had a dehydrogenation example that you used as that one, but I mean, that's going to be pretty different to another process on the whole. Because I'm asking more in the sense of how much effort is it going to take in your team per project, per client for each of that fragmented industry?
Yeah, it's a good question. So a lot of the chemistry that happens, so there are a lot of chemical processes out there that just need heat. So if it's just the heating platform, then it doesn't necessarily depend on the chemistry itself. You're not like having to deal with catalysts. You're not having to deal with the chemistry itself, any carbon deposition, whatnot. We are targeting, so for us, we can build customized reactors for really any process that requires heat. But I think if the chemistry requires some extra thing where it's like, okay, you need some mixing or you need some catalyst that can handle the high temperatures, then yeah, we have to sort of, talk through the phase of designing the system a little bit more. So it ultimately comes down to, yeah, who the customers are and what they need. Yeah. But I think our value proposition is that we have so many different features that we can bring into the table for the chemicals company to just kind of pick and choose from what we can do. Yeah.
Coming to the climate impact for a moment, let's imagine the grid as it is, and we're going to plug in one of your reactors and replace a natural gas heating system. So we're going to get a 50% penalty by having to go from fossil to electricity back to heat versus just fossil to heat. Can you talk about the climate impact in that scenario?
Yeah, I mean, it's still better than just going direct natural gas. I think the numbers are, so it's like 0.2 kilograms of per megawatt hour is from natural gas heating. So I'd imagine it's like maybe so I think I showed 3.5 million tons of CO2 avoided per year. If we were to purely use renewable energy, I would say like maybe less than 50% of that if we're assuming your scenario. Yeah.
Can you talk about your team?
Yeah. So Connor and I, we met each other because we're PhD lab mates. So I started on as a power electronics PhD student. My skill set has been in power electronics. To develop this process, you need to build the power electronics because ultimately our understanding was that in the chemical engineering space, like the chemical engineers don't understand the electrical engineering, and to build electrified reactors, you have to understand the electrical engineering. So me and Connor, essentially, we're kind of a fully integrated team where I do the power electronics, he does the reactor engineering. We kind of co-work together. He's built power electronics himself, but we have industry experience from SpaceX, Astronis, and our advisor, Professor Jonathan Fan. He's an incredibly knowledgeable advisor who's been able to like kind of be the brainchild of this project. So yeah, and we've been researching this for the past 5 years. So yeah.
Thank you. Next up is Interlinked. The team, please come up. Thank you.
Hi, everybody. We're Interlinked and we're ready to go. This was the Palisades fire early last year in California. In just the first 20 minutes, it went from that single ignition point to over 200 acres in burn. It was a disaster before anyone had seen it coming. But what if we had seen it coming? When seconds matter, why are we 20 minutes behind? It currently takes emergency response and fire departments 20 minutes to get an accurate map when going into a fire or a disaster. This is caused by two major issues: outdated static mapping and a lack of real-time insights. And unfortunately, this leads to loss of life, loss of infrastructure, and millions in preventable damages to society and the environment. To truly paint the picture, I want all of you to imagine yourselves in the boots of a firefighter. These are some photos from one of the organizations we work with, CAL FIRE, and while you see smiles on the left, I can confidently tell you, if you look at the right, there's nothing to smile about. Fire departments have to track an unparalleled amount of factors when looking into the average fire or disaster, from environmental factors such as wind, vegetation, temperature, humidity, to societal factors, movements in traffic, to population density. You combine that with the outdated static mapping and the lack of real-time insights, and I can confidently tell you that firefighters and emergency responders are forced to make life or death decisions sitting in operational chaos. On top of that, that same organization, CAL FIRE, over the last 2.5 years, spent $3.5 billion in suppression costs. Those aren't costs related to the damages the fire causes. Those are costs related to over or under allocating resources going into an incident. Proves it isn't just an operational problem, it's a financial one. And this is exactly why we built Interlinked. Interlinked is an AI command system to predict ignition, map spread, and deliver response strategies all within seconds. No more waiting 20 minutes for a map, no more guessing games, just pure real-time insights.
Now, to put this into perspective, this is the dashboard that the firefighters we currently work with use on a day-to-day basis. We start by calculating the point of ignition, and then we're able to predict the risk of ignition, which is where the fire will spread for both stakeholders and the environment, as well as the optimized routes that firefighters will take and the response strategies associated with them, making fire response data-driven, not instinctual. We do this by fusing together multimodal data, which is data from the environment, the society, and also the instincts of firefighters themselves. We combine all this in real time, and we're able to produce these outputs in seconds. And these outputs take the form of response strategies, telling firefighters what to do and when. Resource allocation, how should firefighters optimally position their active units? And a human feedback loop that accounts for changes in the environment every time they happen. And this is something that's not in the existing workflow of firefighters.
To build a complex algorithm like this, we've partnered with over 50 different integrations from everything that could potentially affect the fire. With these integrations, they come from public and private partnerships. Our most notable partnerships are with Google's Earth-Fire Alliance satellite, which is a satellite to ultimately track in real time. The ultimate goal with this is building a hedge of all the potential things that could affect the fire, from environmental factors to societal factors. The Google Earth-Fire Alliance satellite is something that isn't available to the public and adds to our moat. To talk about our technology partners, we come from a variety of reputable labs back home in Berkeley. Rashil's background is in AI research, and my background is in finance and disaster research. To talk about our funding so far, we've received $100,000 so far in non-dilutive prize funding from a variety of competitions, and most importantly, $500,000 in compute. Compute is our largest cost, so this has ultimately allowed us to keep our pilots very lean. To talk about those pilots, we have around 15 pilots with counties across California. The most notable ones are in Los Angeles and San Diego County. And when it comes to our partner platforms, we realize in terms of a business that fire departments aren't the only ones that could benefit from a model like this. Saving 15 to 20 minutes going to a disaster can apply to all emergency tech platforms as well as utility companies, because utility companies actually cause most of the fires in California. So working with a variety of these companies such as Genesis, Everbridge, and Watch Duty as the larger ones. To talk about this problem further, as I mentioned, there's that 15 to 20 minute latency gap when people are allocating resources going into a fire. We believe as we scale past fire departments, we can work with a variety of different industries, with the most notable ones being emergency management companies, insurance, and utility companies. To talk about our revenue model with our counties, it's very straightforward. The larger the county, the more data required, the more money required for an annual SaaS contract. It's a dynamic pricing model. To talk about it very specifically, though, with our enterprise companies such as Genesis, Everbridge, and Tablet Command, they pay a setup fee as well as an API call model, which means when a fire hits, they ultimately pay per API call, which means every time they have an input into our system, they pay for it. It's based on usage. To talk about our go-to-market and financial projections, by the end of this year, we want to start converting our pilots into full commercial engagements. We have 15 of them, and our goal is to convert a majority. To talk about our plan for next year is going to the rest of the California counties. There's around 40 more that we still haven't touched, and that's our goal to keep going. Most importantly, by 2028 is scaling this across the United States to other fire-prone states such as Arizona, Washington, and Oregon, and then moving to fire-prone countries such as Australia, Canada, and Spain. To talk about the market opportunity, there's 45,000 tech-ready global departments that can have an algorithm like ours plug into their existing stack. As I mentioned, we have two business models, but that also means two forms of product. We can offer our map just as the way it is with our response strategies. We can also have it plug in as an API into existing technology, which means we can also work with a variety of emergency tech platforms the way we are currently. Specifically right now, With our SOM, we're working specifically in California. And one thing this marketing model doesn't show is this is only for fires. We've started with fires for 2 reasons. The first of which is fires are right in our backyard in California. The second is fires are actually the most complex kind of disaster. If we can do it for fires, we can do it for all types. To talk about our competition as well as what's our moat, it's our real-time decision engine. The ability to respond in 15 seconds versus 15 minutes, that's what departments value when it comes to making decisions. This stems from 2 major things, our private data partnerships and our firefighter feedback loops. The private data stems from all our different integrations. What most people don't know about fires is they aren't just caused by the environment, they're caused by anthropogenic factors when humans and random factors cause fires, as well as utilities companies. We've partnered with all those firms that I mentioned to get the most reliable sets from everything that could affect a fire. Utility grid data, calculating when in real time a grid could cause a fire, to factors in traffic. Another thing a lot of people don't know about fires is when they hit, people tend to do 2 things. They stay at home or they will go and block the main road arteries, the same road arteries that departments take to get there. By doing this and partnering with Waze and a lot of traffic companies, we can calculate those routes in our algorithm. And the most important thing that we've learned working with all these departments is each department has their own vernacular, their own way of describing a fire. With our algorithm, having reinforcement learning, taking in their feedback and working with all these departments, it is designed to fit their existing workflows. If life and death is on the line, they need to have something that they truly can speak to and understand. That's what we believe makes us different. To talk about the environment opportunity, we believe by 2030, we can save 6.65 billion trees by targeting wildland-urban interface zones. To quantify that, there's around 8,000 fires a year in California, and the average fire burns between 150 to 200 acres. Wildfire, not normal fire. But pretty much, these are our calculations, stem from working solely in California, and as we scale to other wildland-urban interface zones, this is what we predict. Moreover, LA alone, which is our largest county, has around 5 to 10 million residents living in a wildland-urban interface zone, which is a zone that is at risk during a fire. Our 2 main pillars are community stability as well as infrastructure protection. By working with all these utilities companies as well as finding key infrastructure on our maps, we can ultimately help identify which resources need to be protected first, which is something that helps make firefighters more proactive and data-driven rather than instinctual. To talk about what we'd use the money for, right now we've been working at Godspeed in California. We want to ultimately start doing this across the other states. We've already built relationships with departments in Colorado and Arizona outside California. This money would allow us to go there and start testing this very efficiently. To talk about our team, we come from deep, diverse backgrounds in AI research, finance, disaster strategy, and environmental strategy, and have advisory from the firefighters themselves, as well as private firefighting, disaster research, and AI ML research. We're all based back home in Berkeley, but we want to take this across the country and across the international scape because fires are a global issue. Now, wildfires move fast,
But Interlinked moves faster.
Thanks, guys. That was great.
Thanks.
Could you walk us through your pilot a little bit? I'm impressed by 15 pilots. I want to understand what that experience is for the potential customers and how you convert them from free pilots into paid customers.
Great question. So right now, we started majority of our pilots, 10 out of the 15 started last year during fire season, which is July. So our first goal was to first identify the problem and work with these departments to see how we could possibly integrate this into their existing workflows. Because one thing about firefighters is they don't like learning new technology. So one thing that we did was design this to be an API to plug into existing technology. That's allowed us to move a lot faster working with government procurement. The reason why we work with all these different counties is to assess the speeds when we work with them. So specifically what we do is each county has a request for proposal process, which means we have to get this approved by a state budget, by a county budget, right? So that's very important. So what we've done is build champions with all these different counties, working with the chiefs. They are the ones supporting and vouching for our product. To talk specifically about timeline, our goal is once this product is ready, which means it's responding perfectly in real time, and it's designed to respond for each different type of county and the vernacular that they have. The goal is going through that RFP process, which means they have to approve it within budget. The fact is, I mentioned there's $150,000 to $250,000 range, which means more approvals acquired. If there was less than 25,000, we would already be getting paid. But ultimately, working with these counties and having the fire departments as our champions speeds up the process.
Maybe just jumping in on that. So how did you settle on 150 to 250?
So that's the money, I mean, that's the willingness to pay we've received from our counties. Ultimately, we believed when we wanted to start doing this, working with CAL FIRE, which runs the entire state, we thought we could charge between $1 million to $2 million for something like this. But specifically at the county level, it depends on the size of the county and the zones in the county. So very specifically, when you look at a county like Los Angeles, it's a lot larger than a county like Alameda, where we're based in Berkeley. So it depends on two things: the amount of data that goes in and the amount of size of the borders and the perimeter of the county. The money that the range we've received is from two things: our costs, our average, to talk about our cost, specifically, to talk about our unit economics. Our average cost for each county is around $3,000 to $4,000 on our compute, which is our largest cost, as well as the data. But the average we charge per month is around $12K. So that's what we've realized from our pilots, and realized the way to make 70%, 80% margins is by charging that amount. And what we receive from the counties is it is in their range. We just have to get it approved, which makes sure that the tech works to the level we say it does.
Could you elaborate a little bit more on the data sets that you have access to that would be proprietary or that other would not have access to?
Yeah, definitely. So in terms of the data sets we use, we have partnerships with a bunch of private data sets like Google FireSat, and we use a bunch of imagery as well, public data sets like NASA. One thing that we do that's different is, since we're making real-time predictions in the environment, we want to have the most accurate data possible, and that's just not a thing right now. So what we do is we built models to actually take these static maps, for example, vegetation or terrain, and actually create a dynamic version of those using machine learning methods and models, and satellite imagery laid on top of those.
One thing to just, I'll just take the mic. Yeah, one thing to just add on is, in this space, there's three areas we need to cover with data: the environmental side, the societal side, which is traffic, movement of people, population density, and most importantly, the responses from the departments. So for the third sector, responses from the departments on the ground, we have recordings tapped in. We utilize a process called Broadcastify, which ultimately allows us to get the real-time talking discussions from our departments. That's one realm. When we work with the environment, the reason this problem exists is due to the outdated static mapping, which means the data doesn't update in time. So when I mentioned in the pitch, one thing we do is combine all these sources into something called an ensemble, which ultimately allows us to hedge them over each other. Let's say one of them has an issue. The most important thing with that ensemble, and what gives us our speed, is it weights certain things in certain areas more. For example, if we're working in Los Angeles, there's a lot of hills, topography plays a larger role. If we're working in the bay where we are, wind from the water comes in, that plays a larger role in all the fires. So the weighting allows us to move fast. But to specifically talk about data and latency, the big thing that we have done is build partnerships with a lot of data sets that aren't available to the public. The most notable one is Google FireSat, which is the one on the top left. That isn't available to the public. That gives us, it's the backbone of our algorithm. And if you ask yourselves, why wouldn't Google do something like this? It's because we've gone and sat with every fire department and learned their lingo, learned their vernacular, and why Google made us a commercial provider to get access to that satellite.
Maybe continue to build on this thread. When I think about AI-driven insights moving into action, I think quite a bit about trust, and I think about workflows. Can we maybe take both of those? So yes, you're pulling from some proprietary data with Google's Earth-Fire Alliance. How do you think about the insights you're bringing forward being trusted by those that you're partnering with? And then how do they ultimately, get those insights to becoming something decision actionable in the way in which they're working today?
This is a great question, my favorite question, because one thing when we first started testing our pilots, our AI would tell them everything related to the fire. They can't digest that in real time when they have to make these decisions. So one thing we've done, working very vividly with these departments, is do two things. We designed it to be an API to plug into an existing map, which means it's already going to plug into a tech stack that they already trust. That's the first thing. And the second thing is designing it to fit their language, fit their vernacular. So just to really paint the picture here, a department in LA describes a fire very differently to a department in Alameda, where we are, right? All of them have their own language. It's like they're their own villages. So that means in terms of perfecting it, there's a really important situation that we have to do. So when we first start, we sit down with these departments, identify the key terms they use, and then tell the AI, utilizing the reinforcement learning that we have, to take in the feedback to design it to respond like them. Obviously, at the end of the day, the only thing that matters is their decision. Will they trust us? Our main goal is to be suggestions for them because they're the decision makers. They're the ones seeing the fire. We're providing suggestions to help them make their decisions. That's all it is. Getting the data there faster and having it organized in a conversational format that responds in the way they like, in their language, as well as fits their existing tech stack. So that's ultimately how we build the trust. And also, firefighters, like no pun intended, this industry spreads like wildfire. So when we work with one department, they go and tell their other departments about our experiences. That allows us to build trust, especially in the political climate.
Yeah, if I may add to that, one thing that we also do is, in addition to the reinforcement learning and the feedback loops, taking into account the actual features that firefighters value themselves specifically, we train all of our models from scratch because general wrappers cannot provide the intelligence for firefighters in the moment. Right? Yeah, exactly. Too many hallucinations and general insights. We want very specifically to tell firefighters what to do with their resources in real time and use their vernacular for each specific department. And so that's why we cannot use just a simple wrapper. We train all of our models from scratch and the actual agentic core itself.
Yeah, that adds to our moat as well.
Let's talk about total market size.
Yeah.
So California has this nice combination of lots of resources, fair amount of tech willingness, and fast adoption.
Yeah.
What's the plan to break out of California, and how are you going to get more conservative departments to adopt?
Great question. So when we want to move outside California, that's why we actually partnered with the majority of those environmental emergency tech companies, primarily because a lot of these companies have bases in these other states, in these other areas, has allowed us to open and start speaking to these departments. We've already built relationships. Other thing is there's national bases of fire department communities. The firefighters all speak on there. It's allowed us to kind of meet departments outside to design this for external opportunities. And to talk about the market size, there's 40,000 tech-ready departments. That specifically means departments that can take in an algorithm like this. That's from learning from our departments and their communities. It's like a fraternity with these fire departments. So that's kind of how we run it.
This is an impossible question to answer, but I'm still going to ask it. Walk us through your case study of the Palisades fire. Let's say your solution was in place when that happened. What would have gone differently?
Great question. So the Palisades fire was one of the strongest fires that has hit the Western sphere in the last 10 to 15 years. So the only thing that we could have hypothetically done with the Palisades fire is gotten them there around 25 to 30 minutes earlier to make decisions on the large masses. The thing about the Palisades fire, it was this completely infrastructural, there was complete infrastructural damage. What we would have hypothetically done and what the algorithm told us when we ran the simulation on it was send more choppers, send more battalions to the left flank of the area of Palisades. So that's near the water, allowed them to ultimately get a higher ground on the mountains, because what happened in the Palisades was they came down from the Palisade Hills into the people, destroyed all the homes. So ideally what they didn't identify was they didn't identify the fact that they needed a better aerial view. Our algorithm takes into the fact drones, imagery, takes everything on their resources. Rashil mentioned the allocation of resources. That's the most important thing other than speed. But the thing with the Palisades, it was something completely unprecedented. Our fire departments still are questioning it. So it was a larger case. This is for the rest of the fires that aren't anomalies.
Yeah, if I may add to that too, this is just one case, right? The Palisades fire. But what we do to actually test our algorithm and make sure it's working in real life scenarios is we test it and we run simulations on fires that have happened in the past. So we see where our algorithm is actually telling firefighters to position their active units, where the fire is actually going to spread, and then we map that to the real life scenario of what happened. And that's how we're able to actually get that accuracy rating.
That's a great point, because in Irvine, like around 8 years prior to the Palisades, there was a similar structural fire. So it literally pulled decision making from that. So that's why I mentioned the choppers, the helicopters, getting those in an area earlier.
Thank you.
Great, thank you. Next up is Iron Lattice.
Awesome. Thank you for having us. We're Iron Lattice, and we're working on more energy efficient and next generation chips. Data center expenditure is projected to reach nearly $3 trillion over the next few years. And there's two major problems it's facing. The first is energy consumption, and the second is memory shortages. Energy consumption is projected to rise by nearly 600 terawatt hours annually by 2030. And for memory, there's articles every week about high bandwidth memory shortages, with capacity blocked until at least 2028. And even when it gets filled, these products have a 3-year replacement cycle. Iron Lattice addresses both of these issues. On the energy consumption front, our chips use 90% less power. This can result in 50% energy reductions for the entire system, or the equivalent of a country like Germany in terms of climate impact at 2030 levels. On the memory front, the most exciting part is that we unlock new manufacturing capacity. So our tech can actually be dropped into logic fabs. Today, 3 major players control most of the memory manufacturing: Samsung, SK Hynix, and Micron. Their gross margins have risen by 20% in the last few years alone. But with us, companies like Intel, TSMC, and Global Foundries would be able to unlock manufacturing capacity for memory themselves. Now, how do we actually do this? We use a ferroelectric layer. Ferroelectric materials are materials that have a spontaneous electric polarization. And when you apply a voltage, you can actually change the direction of that polarization. And it retains it after you remove the electric field and the power. And this polarization essentially is the state. So 1 or a 0, depending on the direction. When you remove the voltage and you don't need power anymore, you remove the need to refresh or continuously power the device. So that's how we're more efficient than DRAM, which is kind of the source of the high bandwidth memory we're talking about today. For NAND flash, we actually are much more efficient because the way that you read or write or that you change the state is you apply that voltage, and we can do that at voltages up to 90% lower. So there's another area that we're fundamentally using less energy. But probably the most exciting application of our ferroelectric layer is the ability to combine compute and memory. So the majority of energy today is wasted shuttling data between compute and memory. But our ferroelectric layer would allow you to combine both and do it in the same place. And this is what is really exciting about ferroelectric materials. Now, why haven't ferroelectric materials been used before? This seems amazing. The major problem that they have faced is historical reliability issues. So for memory and compute applications, you need to be able to cycle these devices from 10 to the 6 all the way up to 10 to the 15 times. So trillions of cycles. Historically, ferroelectric materials in lab could only get up to 10 to the 3, so nowhere near close enough for commercial applications. In the lab scale at Rice University, we've demonstrated 10 to the 10 cycles and have a roadmap to 10 to the 12 and beyond. So that's more than good enough for commercial applications. One of the second major breakthroughs is that this is actually drop into existing fab technology today. Standard can be used with standard atomic layer deposition processes, and we've actually confirmed this in person with a major R&D fab in the United States. And finally, what's very exciting is that we use standard materials. So no rare earth elements, no conflict minerals, and the potential for a domestic all-American supply chain, which is becoming an increasing priority for this country.
And so I want to talk a little bit more about the production process. A lot of research labs today, they have new materials, new architectures, new chip designs, but the common challenge they face with all of these is that they can't be made at commercial scale. But Iron Lattice, we are a true drop-in. Like Ben mentioned, we've been able to validate that we use today's materials, today's techniques, and we can work to do without any new custom tooling and techniques. Our strategy used to be capital-light, similar to how NVIDIA operates. We'll contract the production to other fabs, tier 1 R&D partners, such that we can have a multi-sourcing strategy for a resilient supply chain, because we don't have to make it ourselves, because it's available in commercial fabs today. In terms of the market cap, between DRAM, NAND flash, and AI compute, this market is about to reach a $715 billion total addressable market. We're looking to target DRAM as our initial beachhead market because of the refresh cycles, the bottlenecks, and talking to the hyperscalers, they've mentioned that if we can build it, they will integrate it. Looking at the DRAM competitive market today, there's a few options. Like Ben mentioned, there's a few major players today heavily investing in high bandwidth memory and DRAM. These tech solutions face the same problems as the power consumption. Whereas while Samsung's investing in new and emerging technologies, like magnetic RAM. They solve some of the power challenges, but they don't solve the durability, the write speed, as well as the ability to be made in commercial fabs. Iron Lattice, we've solved the power issue, we've solved the speed issue, and we've solved the production issue. Today's incumbents are still looking for a solution. Samsung, they've invested in some ferroelectric materials, but they've only been able to reach durability cycles of thousands or maybe tens of thousands. With SK Hynix and Micron, they're still continuing to invest in DRAM. While these are solutions today, they're not sustainable long-term given the power consumption and power demands. And we've seen in the market that there is demand for new and emerging solutions. Grok and Ampere, they've used today's existing memory technologies, and they've been able to create new chip designs and architectures to target AI workloads. And they've been able to exit for $20 billion and $6.5 billion respectively. With Iron Lattice, we have a new memory technology and new designs to really improve the AI workloads by improving the power efficiency and scalability for AI workloads. So we believe that we'll share a similar financial outcome. And so where are we today? Today, we've been working heavily on the go-to-market and partnerships. We've actually signed a letter of intent with a major OEM to integrate our chips into their consumer hardware when we reach production. We've talked to hyperscalers. We've gotten interest from 3 out of 4 to deploy on data center infrastructure. And we've also gotten sector-specific interest, showing that our chips have a lot of potential. In terms of the technology, we've been talking with this $30 billion R&D fab to validate our commercial production and tooling. We've created it in the lab, and now we want to create it in a commercial setting. We've improved the durability from 10 to the 6th to 10 to the 10 cycles in the last 6 months and are continuing to improve. From an IP perspective, we have multiple Rice University patents filed and are looking to negotiate with the licensing office to be able to share the data and IP with manufacturing partners. We're seeking this prize to help us continue fund the lab scale validation and prototyping, as that will be very resource intensive and take time to help us bring this to market. In terms of the milestones, we've been talking a lot in our go-to-market. We've been talking to hyperscaler partners. We've been talking to foundries. We've also been talking to domestic edge computing. And we are actively having conversations with the logos that you see on the right-hand side. And we're looking to continue to validate with them, 1, the power consumption benefits, 2, the commercial use and validity in DRAM and memory applications, and looking to execute these partnerships to commercial use. From a technology perspective, our technology is currently validated in the lab environment. So that's why we're working with foundries to make sure that this can be produced in the commercial facilities using today's technologies and today's techniques. The prize money will help support the material testing and tooling, and we're looking to continue to improve the durability and capabilities of the material to match what's currently given from the DRAM capabilities. So I want to talk a little bit about our team. Ben and I, we've done a lot of partnerships. We've worked in the clean energy and renewables space, but we have decades of experience backing our team. We have a lot of experience spanning from working with semiconductors from business problems to actually people who have worked in the semiconductor industry, bringing and manufacturing semiconductors. We also have the backing of Dr. James Tour. This is technology that came out of his lab. He has spun out 52 of his current technologies, and 2 of his spinoffs have become publicly traded semiconductor spinoffs, and we're looking to be his 3rd. We're Iron Lattice, and we're really excited about the future of compute, and we hope you are too. Now we're open for questions. And we have some other members of our team if you want to join us for Q&A.
I'll start. Hey, congrats, gents. Yeah, I think getting to the number of cycles you're talking about is critical for something like this. A lot of the other ferroelectrics have run into that durability issue. And so maybe can you share a little bit more with us on what allows you to do it? And then, how defensible is that when, the Samsungs of the world would want to put 200 people to try to quickly replicate?
I think the details are a bit proprietary, and Fred is kind of the IP guy, so he can maybe talk about how to defend it against Samsung. But essentially, we're working to kind of structure layers of the material to improve the reliability. So it's kind of a device engineering concept.
I can add on a little bit more. I think, and Jeho, our CTO, is on the phone. He's listening in, but in simple terms, we're called iron lattice because of the super lattice structure. And that super lattice structure is our proprietary IP, which is what holds it together. So it's what allows the durability to get to that level of cycles that you see. And actually, the only thing keeping us to get past 10 to the 10th now is we keep breaking the machine that does the testing because it can't go past that point. So one of the reasons we need to work with a more advanced fab is they'll be able to test it past 10 to the 10th. But it's a very good point. And then from an IP perspective, so just by the way, Tawfiq Jarjour, CEO, and then this is Fred.
Hi, Fred Fludge, Director of Innovation with Iron Lattice. And as the guys mentioned, we currently are developing a portfolio of patents. We have applications, nothing's public yet. So unfortunately, I can't really go into the details, but as described, the innovation is in a different way of using standard materials to create a ferroelectric layer that doesn't degrade. It has the proven aspects there. Our IP is focused on trying to protect that in all material that we can conceptually use in making such a lattice, and we're also continuing on. So I hope that gives you a little flavor of what our strategy is. Our core intellectual property is our ability to protect from the competitors at this point.
Yeah, and then we're happy to answer more questions about that separately.
What are the key technical milestones that you need to pass moving from TL4 to TL6, let's say? And to some extent, what are the main risks that you anticipate to scale reaching a TL9?
Right. So a lot of the information we have today is from the lab validation environment, just because the lithography that we have is not at the higher resolutions. So talking to our fab partners, they have, obviously higher resolution. So we are looking to validate that the structure that we're building today is replicable at the smaller scale. We don't anticipate any major challenges just because of the way that the structure is built, but that is something we're looking to validate with the commercial fabs. And talking to some of the potential go-to-market partners, they want this third-party external validation, which is what we're looking to do right now as well.
And just taking you through a very specific timeline. So we've confirmed, like we said, with an R&D fab, we have a plan for them to both test the technology so that we have third-party testing. They're going to recreate the technology to prove that it can be replicated outside of our lab. And then the next part is we're working on the scaling process. So if we get those three in place, that scaling process is going to allow us to build a physical product that they can put. We already have a physical product, but like a physical chip that they can stick inside of their testing spaces. And that's where all of those partners are interested. So once they get it, they'll be able to test it. When they test it, that will take us down that pipe. And then we just need to build the right mask layers and setup in a commercial fab like TSMC, Intel, Global Foundries. And once we get it set up with them, we may, though, just as a side approach, we may take it through our defense partner as well in parallel. But whichever one we take it towards, that will take it to TRL 9. But the good news is we have a very, at least in semiconductors, a very clear path to get there. And thankfully for us, we don't have to raise the tens of billions of dollars to build it. So we'll partner with fabs who have the existing techniques and materials. And some of the ALD machines and others we have are hundreds of millions of dollars just for the tool. So if we work with them, it's going to make it a lot easier to unlock the value. And this is why our approach has to be a consortium of partners. And so every one of those companies you saw was interested in working with the others. And they actually introduced us to the others that were there. Because the consortium is how we can succeed. You can only transform an industry like this if you work with everyone instead of just one company.
Yeah, if I can jump in with a question. I mean, roughly speaking, the timescale of bringing this to market is the timescale at which traditional technologies can resolve the memory supply shortages. Like you could stand up a DRAM factory in roughly the same amount of time. What are the durable advantages of your product in a world where memory is abundant?
Yeah, certainly. So one thing is that while DRAM bottlenecks can resolve in the future, the biggest thing we see is the 3-year refresh cycle. So given the advancements of memory and AI, right, they're going to have to rip everything out in 3 years to build in with the newest and latest. Another thing is the power reduction usage. Because we don't have to actually transfer data back and forth and the memory is stable, there's no refresh power, such as when DRAM uses capacitors today to keep the bits stable. We're able to generate significant power savings, which we see will be an advantage, especially when companies consider what technologies they use for their hardware.
So just to build on that, I get that there's kind of a memory play, and then there's potentially an in-memory compute kind of larger play that you're looking at there. On that second piece, I mean, there's a huge number of companies, right, pushing that. Some have raised billions, right? You know, you've got Grok up there, but there are many others. What's going to be your winning in that? Is it going to be around, I don't know, inference and the kind of tokens per second? Is it going to be around power? And then how are you going to navigate that exceptionally noisy competitive field?
Yeah, there's additional slides we have that compare us to every one of those technologies. I'll say in simple terms, it's the type of memory we're using and the characteristics of that memory. Most of the technology that's being used, so like Mythic AI is one of these companies, most of the tech that they have is actually based on NAND flash. And so whenever you base your core tech on something like that, it's very slow. We're about 1 million times faster than that. So the speed difference is a big challenge for others. And then the other is so many of these companies who are putting in their bets on it are using proprietary materials and like materials that are not standard in a fab and not standard for fabrication process. So like while Intel has had through their, I think it's Lohi, their chips, they have some really promising results, they can't manufacture it in mass. And our two differentiators in that regard is that we have a different type of memory that's much faster and will be more responsive. And then we can build billions and billions of units, no problem. And I think that's the key because it's a space we actually know fairly well. A little bit of my background and Fred's and some others, we've been connected in the semi industry now, my whole career, Fred's whole career, and others in here. But we understand where their challenges are, and it really comes down to where you start. And so if you have different materials in there that are not standard in a fab, you're going to struggle to manufacture in mass. And I think that's usually what's keeping it from becoming. Otherwise, they've been spending money, like you said, billions of dollars over these past several years. There's a reason that none of them have reached mass production. So.
Thanks, guys. It's essentially another TRL question, but have you been able to shrink this to the industry relevant length scales? Because sometimes you see wonky material properties at those scales.
Okay, so I'll give you an idea. Right now, I know Jeho's on the phone, but we're at 2 microns, right? Yeah, we're on 2 microns. That's about the best we can do in the university fab. In the fab that we were talking to, we actually met them on Monday, the fab we just visited. They have a roadmap for us to take it with them to 65 nanometers, then to 28, then to 14, then all the way down to 2. So we should be able to take it to 2 nanometers. We just need to test. And we went through, I can't share all of the results and the information here, but we should be able, based on our design, to have insulation from the different layers interacting with each other. That's part of the proprietary design. But that's something that, as part of the next, let's just say 2 years of this process, when we have the physical test chips that will go, those will be in those smaller 28 or around that nanometer scale. Yeah. So.
Can I sneak in one last question to ask? What is the programming model on top of this? How will it be adopted by the actual engineers making AI models?
So there's actually 2 ways of us doing it. There's one that we can think of existing technology that's there and we can plug into that tech. And so it would be using the same programming language, the same information that's there, because we operate as an example, the 3-tap, it's a transistor. So the same way you would program a transistor in other regards, you do for us. There are also a few smaller software startups that we've connected with and that we've signed intent information and agreements on. And we're testing out their proprietary new software to basically have a new programming language on there. And part of it is, you noticed, we mentioned a little briefly that we have up to 32 different like memory states. They're working on a kind of software that can translate, think of like a Rosetta Stone to go from what most software looks like to our 32 different states. So but I don't think that's where we're going to start. I think we'll start with something a little more standard and we'll have that going on in the background. But very good question, because that is the difference of why we're going to memory first versus compute in memory, because compute in memory is going to involve a whole set of reprogramming, which is why we might have to work with partners. There's some I can't mention today, but they're interested in potentially working with us on that bigger challenge. But that's a very, very fair point.
Thank you. So now we're really excited to have our keynote speaker, Marianne. So I'm just going to switch sides quickly and then give a brief introduction. One second. I'll figure this out later. Actually, I'll give the introduction and then I'll have maybe one of my team members come up and help me figure this out. So Marianne is a longtime climate tech investor and venture partner at Congruent Ventures. Marianne previously served as president of GE Ventures and partner at More Davido Ventures. At Congruent, she works closely with portfolio companies at growth inflection points, helping to determine optimal financing strategies and scaling pathways. Marianne has a PhD and an MS in electrical engineering from Stanford and extensive experience backing industrial decarbonization and tough tech innovation, bringing a mix of technical rigor and an investor's perspective. So we're thrilled to have her with us today to share her insights on what it takes to build and scale climate solutions. And if you'll give me 1 minute, I'm just going to figure out this tech issue.
While you're doing that.
Yes, please. Go ahead.
So, hey, good morning, everybody. I'm Marianne Wu, and I'm thrilled to be here speaking with you. I'm really looking forward to the program today. The first 3 companies were amazing. And so really just the quality and the scale of the challenges and the quality of the entrepreneurs that are coming to the space is really exciting. And as somebody who, as May said, has been in this space for, frankly, a couple of decades now, it's really encouraging to see the progress and the sustained energy around this space. To start, I'll start with introducing myself, which May already did a little bit, but maybe more about Congruent Ventures. And I don't know how many of you have heard of Congruent Ventures already, but we are a San Francisco-based early stage climate-focused firm. So we invest broadly across the climate landscape, only in North American companies. So for the semifinal, this is perfect. This is the Americas, but we do select for companies based in North America, and we invest very broadly across the climate landscape. So that's hardware, that's software, that's materials, that's business models, the whole gamut. In terms of sort of fund size, we're about $1 billion under management at this point. We are very active. We have, I think, north of 50 companies in the portfolio. We do participate broadly. Oh, I think we're getting there. We do participate sort of in a variety of modalities. I'm just kind of giving some context so you understand who we are and our perspective. So we will lead, we will co-lead, and we will sometimes follow. So we are very active in the investor landscape. Is it not working? Oh, no worries. Okay, so while we're working at the tech issues, and as I said, we invest very broadly across the climate landscape. And the climate is in itself kind of hard to define. Like, what is a climate tech investor? So we think of it in terms of 4 main macro segments that we group our investments around. And these are just huge industry swaths. So they're just sort of macro labels that are helpful for categorization. One is urbanization and mobility. So we're seeing an entire transformation. Obviously, these are big emissions categories too. But we think about mobility in terms of transformation of how we move people and goods around and how we can do that more efficiently, more effectively, and decrease the carbon footprint. And the same thing in our built environment. How can we make things better? One important thing I should have said at the beginning is we are a returns-focused investor. We are not a concessionary investor. We're not a catalytic investor. We are a returns-focused investor. So what we're looking for are great companies that also have climate benefit. And that is, I think, our thesis on the opportunity here. These are massive markets. So there's the opportunity to build highly profitable companies at the same time as delivering climate benefit. So that manifests itself in terms of these categories that I talked about: mobility and urbanization, obviously energy transition and the big drivers across energy transition, and then food and agriculture. I'll skip over this. Food and agriculture as another macro category, and transformation of our food systems and agricultural systems, and also our natural systems in terms of how we think about improving our natural systems. And lastly, sustainable production and consumption. And this is a really big bucket, but how can we produce goods more efficiently and effectively? How can we perhaps change our consumption models as well so that the carbon footprint is lower, and we improve the quality of services at the same time? Some representative companies, actually I'm going to skip the representative companies. You can take a look at it on our website. And I am going to come back and do a couple of case studies at the end that might be relevant for the team. So I already talked about, these are macro, these are big markets. There's a lot of data in the next couple of charts. I'm going to skip over it all, but the point is really just to say that there are massive markets and there are huge investment drivers here. Climate impact is important, but as you're building great companies, you really have to think about the economic opportunity and customer, and not just the macroeconomic opportunity, but specifically who you're going to sell to and what problem they have and why it's an urgent problem. And we're going to come back to that as we talk through this a little bit more. But as I said, I have a bunch of these macro slides first. And so if we think about energy transition, the big thought here is that renewables penetration is increasing and the price of renewables is going way down. That has caused some problems. It's not all perfect. Cost of energy delivery has actually gone up. The grid is desperately behind, and I think we all know this. The really big driver, and I think everybody in the room also knows this, the really big driver here and the big change that has occurred in the last couple of years is energy growth, and urgent energy growth and urgent access driven by data centers. So if we think about developed world energy system, it has been a declining energy environment for decades. It has not been an investment in expansion of capacity, and data centers are really changing that. If we think about mobility and urbanization, you can just see some charts here that highlight how significant EV growth has been and the potential economic market business opportunities that come from that EV growth, and at the same time as the need to drive down the energy intensity of our cities. If we think about food and agriculture, we've had incredible productivity growth in terms of yield per acre. And that's been an incredible transformation for our society. At the same time, there's a whole new set of capabilities around automation, around more biologically oriented solutions that can also continue to accelerate this and perhaps improve the quality of our lands and soils as we've seen the decrease in arable lands. And again, this is just all macro framing. And then sustainable production and consumption, we see, what have we got on this chart? Oh, just incredible consumption in terms of continued spending and commerce. And on the right, the sort of increased maturity of automation that we're seeing in manufacturing and the adoption of industrial automation. So these are some macro themes. Ooh, something very strange happened on this slide. Apologies. But everybody always says, so those were big macro thoughts, right? So everybody always wants to know what's really interesting now. And I would say the big driver, like one of the things, last night I talked to a number of you and everybody said, oh, what are you excited about now? And it's a little bit maybe common right now, but one of the big things that is driving a lot of activity is data centers. And people think about that. I think of data centers almost like the adage about elephants. So, you touch the trunk or you touch the tail and you think it's something different. People think about data centers in a lot of different ways. Certainly speed to power is one of the big issues right now. And when we think about climate and energy, most people think about the consumption side, like how do you power these things? But if you think about a data center, it's really a factory that converts energy into tokens, which are insights. And so what data centers are doing right now is they're actually transforming our energy supply system because they need more power to power them. They need more energy to power them. They also need to make everything, as we heard from Iron Lattice, much more efficient in terms of how they turn that energy into an insight. So what data centers are doing right now is they're actually transforming and upgrading our energy supply chain at the same time as we're reinventing our tech stack. So the whole kind of basis of major segments of our economy are being reinvented right now for data centers. And they're also really, when we think about opportunities, we also think about like, why now? You know, what's happening that triggers a change in behaviors? And one of the great things about data centers is there's a lot of urgency, there's a lot of money, and they're brand new problems. So that creates sort of like this perfect white space for new invention. And that's, again, why you see a lot of data center-centric startups coming. The next one is obviously a sort of direct follow-on companion for that, and I'd say that's AI for X. And we've already heard that a number of times today in terms of the companies. But AI is in terms of why now. AI is a new tech capability that allows us to do things much more efficiently across a number of domains. And then generally those don't, not always, but they get kind of married with new problems. So some solution that we haven't needed to have before, that combination creates a lot of white space for new entrants. So you see AI for resource discovery, AI for materials invention, AI for wildfire coordination, AI for X, where that AI provides the kind of efficiency to being able to do something we couldn't do before, but now maybe also married to a problem we didn't have before that creates that perfect nexus for a startup. Robotics, this one we're seeing across a bunch of industries. I had that one chart about industrial automation increasing in the factory. That's allowing robotics now to penetrate into a lot of different industries, whether that be solar panel maintenance, agricultural robotics, robotics for sorting. We're just seeing this penetration of robotics into the physical world as an extension perhaps of that AI for X, that we're taking that intelligence about the physical world, largely in this climate space, and then we're marrying it to actuation. This one I put as risk repricing around climate, but it's really the increasing incidence of natural disasters. Sadly, the increasing incidence of natural disasters is driving a whole rethink around what climate risk is, and certainly that shows up as an industry and insurance. It's also driving a whole new set, and we saw one company this morning, I think there's another one this afternoon, about companies that are trying to prevent the damage outcomes from these natural disasters. This is certainly a super active area in terms of adaptation, and specifically wildfire as the big driver in the near term around this, although for risk repricing, floods are a big one. And then the last one I put was critical minerals, and this is really kind of the new energy supply chain as we move into more electrification, as nuclear starts to rise in interest, then there's a lot of interest now around those new minerals and that new domestic supply. So those are super active areas. In the next part here, I was going to shift a little bit to starting, what does it take to start a company and how do you build one? And I had asked the organizers, what do you guys want me to talk about? And this was a set of questions that were provided. And they were really largely, if you look at them, they're all about capital. They're forms of how do you raise money? What do investors, how do investors raise? How do investors evaluate? Why is climate tech or deep tech or tough tech hard? So I thought I'd just talk about raising capital. And so if you think about it in terms of how you start, if you're just getting started as a company, you have some idea that you think is worth doing, and you have a founding team. So that's what you have. To be a successful company, you have to attract team members, you have to attract talent, you have to attract customers, you have to attract partners, and then you have to attract capital. It seemed like the questions were not so much around the first three, that people kind of felt like they knew how to do those ones, but the capital was the mystery. So I'm going to talk about that, although it's going to intersect with the top three as well. So Apologize, these are super ugly charts, but hopefully they make the point. So when you raise a company, you are increasing the enterprise value. When you start, you have very little idea. This is obviously just a hypothetical chart that it kind of goes up to the right unevenly. In practice, founders, to the extent you have a value that goes down, that's not weird, right? Like you can live through it, but your enterprise value goes up and to the right as you develop your product, as you get more customers, as you have these value creating milestones, as you move through company stages. And you need to raise capital to do that. And the shape of these curves will change, obviously, and all companies start, well, not all companies, but venture-backed companies generally lose money before they make money. And before they can finally get to the holy grail of the exit. So the things that really matter in terms of just sort of the big buckets at the kind of financial level are how much your company is worth. Like if it's successful, is it a valuable company? What are the metrics that you can create value along the way? And then how much is required and how long it takes. So I'm just gonna sort of talk about these a little bit more. The first thing is how much is your company worth if it's successful? And that's a function of the market. And so you can think about it at the top level. Can a company get to significant revenue? A good benchmark is like, can this company get to a couple hundred million in revenue? And if they do, how valuable is that? So that's a function of some industries are more valuable than others. And so that's reflected in the enterprise value. But this is critically a function of the market, how big it is, but also is that a market that is willing to pay? Are there customers that are willing to adopt new technology? And critically, are they willing to adopt new technology early? So there are some industries, industrial tech, heavy industry, utilities, they are historically risk-averse customers, so they love to be second. The adage is they love to be second. In truth, maybe they love to be fifth or something like that. So where do you get started? And then if they're super attractive markets, then you're going to have a bunch of competition. So what's your long-term differentiation? And is this a team that can do that? The second thing that I think also tends to get overlooked is the value creating metrics along the way. So sometimes the easiest proxy is revenue. In climate tech or deep tech, sometimes it's a long term until you get revenue, long time until you get revenue. So what are you actually building value with along the way so that the value of the company goes up so that you can raise money based on that progress? And so, those are the two things that are different, right, along the way is can you create value milestones? What's the enterprise value? Then the other thing that matters, of course, is the total capital required and the timing relative to the valuation. So I'm going to do 3 little mini case studies right after this. But a lot of times, climate tech is super broad. Some companies are very tech-like. That you have a pretty standard product development, you get revenue pretty early, then you're just figuring out how you execute. Some companies have long tech development before they ever get to revenue. So how do you get value inflection along the way? How do you increase the value of your company? What are those kind of milestones that you get that increase the value of the company that you can start to raise capital? And can that capital raise come after you've done the value inflection? So I promised 3 little case studies, just doing a quick time check. And I'm not going to go into any detail on any of these, but I picked 3 different companies that are represent different parts of the climate value chain, different types of market segments that they're in, and different types of business models. So Fervo is a energy developer. It is a project finance business model based on a new technology applied to geothermal. Span is a product developer. They produce consumer devices that are tech-based, that play into long-term trends around electrification. And Pano is a services company providing services around early wildfire detection. So 3 different business segments, 3 different business models, 3 loosely different capital profiles. Fervo is perhaps the one that might be most informative to some of the questions that people were asking in terms of tough tech, capital intensity, groundbreaking research. Fervo has raised over $1 billion. They have really no meaningful revenue against that. So how are they able to do that? One is market risk here is almost nothing. So this, Fervo is an enhanced geothermal company. The premise was that you could take technology from oil and gas around horizontal drilling, bring it to geothermal industry, transform the economics around geothermal, increase the resources and reserves, and provide baseload, zero carbon baseload power. And again, if you marry this now, frankly, this wasn't a big piece of the thesis when it started, but if you marry this now to the data center piece, then of course, zero carbon baseload power is a very much wanted and sought after resource. But at the time of the founding, the market risk was effectively zero. If you can do that, if you can produce that cost effectively, then of course there's people that will buy it. It's a commodity. There's no weird variations in the electron that matter at the end. You have a product that other people will buy. So the entire risk profile at the beginning of this company is, will the technology work and will it hit the TEA that is provided? And can the company raise the capital, right? Like from the outset, that's, maybe you don't know it's going to be over $1 billion, but you know it's hundreds of millions of dollars before it's revenue. So how does a company do that? So they were fortunate, and certainly this is true today, they took advantage of all of these climate entrepreneurship resources that are available. This was a founding team out of Stanford. They did the Activate program. They did a Tomcat program within Stanford, which I know MIT has similar types of things. So they could get started. They validated a TEA. The critical sort of step in terms of technical progress was a pilot facility. They're building a, let's call it a 400 or 500 megawatt commercial facility now, but their pilot facility was 3 megawatts. And it did it drilled two wells and connected them. And it proved the viability of that technology. It also, so that was sort of the big technical proof point, but it wasn't done, right? Like these things are never, oh, you do a pilot and everything is nirvana after that. It worked according to the model. They still had to improve things. So the issue for a company like this is it can't access project finance capital until the technology is validated. But they could still, so effectively venture plus the coalition of the willing funds that through that point. And the value inflection points are customer commitments. So LOIs that say that they would buy if this was available, reserves that are appropriate. So the resource base of the company in terms of the size becomes an asset that you can think of as the value of the company. A project development pipeline, right? These are things you can make progress on at the same time as you're doing technical feasibility that show that you're on that trajectory to being a very large, very valuable company that keeps letting the funding come in. The other piece that was very important for a company like Fervo, given the capital needs, is it was interesting to a lot of different strategics. So Mitsubishi was interested because it would be a whole new market segment for a bunch of their equipment. There's a bunch of traditional energy companies in there, Liberty, Devon, I forget who, but the idea that drilling technology and drilling insight could go into this new growth market was really attractive to a lot of people. So that's how you could that's how that company was willing to raise the $1 billion. And from a venture perspective, given the capital need there, it's how big can this company get? And what's the capital stack that's available to me to raise that $1 billion so that it can become commercially viable? Span, as I said, is a product company doing electrification, selling to, in the end, deploying at end customer residences. So this company has a very different kind of capital profile and risk profile. If you think about it at the founding time, there's almost no technology risk. Span, sorry, what it does is it's a smart panel that is effectively an energy router for your home so that you can control sort of power sources, power loads in terms of how you're directing those things. The value prop is it lowers the cost of energy for the homeowner. It simplifies the installation of new electrical loads in the home. And for a grid operator, it provides grid support. But there's almost no technical risk, right? You can do a smart panel with some power electronics in it and some software. The fundamental question, and there's no long-term market risk. We're certainly going to have things like this in our home. We have all sorts of data networking at home. Why wouldn't we have some sort of power networking in our house? But the risk in a company like this, and there's no, I don't think, there's no long-term market risk, and there's not even market risk around the value prop today or at the time of founding. The risk was all about, can you find those customers efficiently? Because, how do you find those customers in sort of consumer efficiency type devices? It's all in power gen type devices. It's really all about lead gen. Like, how can you find those customers and how can you find them scalably? So that was the market risk. That was the fundamental risk that was being evaluated at the time of investment. And as the company goes forward, how do you grow that revenue? What's the cost? Can you scale your manufacturing to a cost basis that's competitive? Can you scale your sort of sales force effectiveness? So this is really all about financial metrics. Are you getting to revenue? Are you getting to gross margin? Are you getting to cost of sales? And that's how that's how an investor evaluates that company as it moves down up the trajectory of the company. And then the last one here is Pano, which is wildfire detection. Again, no technical risk, right? Like, and what they do specifically is they do early wildfire detection based on imagery. So they start with proprietary cameras that they install in the field. They use AI to detect wildfire when it is first ignition. That allows much, much faster response, which limits the damage the ensuing damage. So in a company like this, there's really, again, no tech risk in this day and age. You can install a camera, they can be networked, you can get detection in place. And there's no market risk in the sense that wildfires are unfortunately increasing. But there is a lot of risk, but it's not wildfire detection is not an existing market. So there's a lot of market risk in not an existing tech market. So there's a lot of risk in the sense of who buys this stuff? What kind of budgets do they have for it? How long is their decision-making time frame? How big is the market in the end? Where does the company grow to from this initial foothold in wildfire detection? So their value-creating milestones along the way were initial customer contracts, a well-defined customer segment with a repeatable go-to-market strategy, customer contracts that were very profitable, that supported the long-term growth of the business, and then kind of roadmap around how do you grow this company in terms of additional customer segments, and additional roadmap. So those are three very different profiles, hopefully instructive in terms of some of the questions you're thinking about. I have very little time, but I will open it for questions right now, or I'll ask you whether I can open for questions or not, but I'll take questions from the audience. Yes. Yeah.
You probably have to raise capital by having 5 to 10 companies come together and invest in building that at the same time. Like,
In the
those
Fervo case,
or in any case that you've seen, yeah.
Well, yeah, I mean, you're a syndicate, right? But you don't necessarily need 5 to 10 at the same time. I'm sorry, what's your question?
So in some cases, like depending on what you're building, like there are some areas we're going to need to raise billions of dollars.
Yeah, you're going to
or-
need to raise quite a bit of
Yeah.
capital. Yeah.
So
yeah.
in those cases, you have a series of a mix of customers. It could be a mix of banks. It could be a mix of others, like traditional, not even like venture capital investors, just traditional ones in there. For these very heavy capital intensive spaces, how do you best recommend building that coalition of
Yeah. I
companies?
mean, it always depends, right? Everything is always, it depends. Typically, a company would start with a financial investor as the seed Series A investor so that you have the early proof points in the autonomy and the sort of the financial first backing. And then you would layer in those strategic partners, those kind of corporate interests, corporate parties that are going to provide meaningful capital, but might have other personal interests in terms of their corporate interest in the company. You'd start to layer those in later. Depending on what they are, sometimes there's exclusivity implied, right? Or first refusals, these kinds of things. You want to limit those as much as possible. And you want to limit the perception of some sort of inside track that would limit the ultimate value creation of the company as much as possible. So kind of rule of thumb is to try and to limit those those exclusionary clauses to the extent you can, and then to try and bring in multiple of the same category type so it doesn't feel like you're beholden to one or the other. That's not always possible, right? So you have to weigh off what they're offering versus what you're getting all the time. Other questions? Yeah, no, when you were talking, it was like, oh, yeah.
How often do you see companies solving tough problems together often work together for strategic partnerships, and how often do you see that like work on an international level and the success of something like that?
Yeah, startups almost always have to partner. With Fervo, I think I talked about it a bit more because over $1 billion, you need large corporate partners that would over $1 billion before meaningful revenue. You need sort of large partners. Span is closely partnered with Landis and Gear, for example. But startups always need to be partnering with others. Generally, you want to partner with somebody. A lot of the time, what you're partnering for is go-to-market strengths, capital and go-to-market strengths. So it tends to be bigger companies. But sometimes when you're building a new industry together, then startups working together is a really great way to drive change in an industry.
Hi there. So I have a question. Maybe you can answer it with like a case study that you've seen. So for example, you've talked about Pano and how like the risks associated with their solution, which is like finding their customer that's actually willing to buy that. So in terms of like problems or solutions targeted at problems, for example, like climate risks or crisis, what the market actually wants, or like the users, it's the solution to mitigate those, right? So it's like they are, for example, buying the service of wildfire detection to prevent them or to mitigate them as fast as possible. So the core purpose of that is just solve the problem of the wildfire. And this is just like one of the services to help with that. So how would you go about addressing that risk in terms of having a startup with a service, but actually the customer wants their solution, like not only being provided with a tool,
Yeah.
but almost as a solution service, you know?
I'm not sure I totally understand the question, but if we sort of stick with Pano, the reason I said at the outside there's market risk, it's a new market, and there's a lot of different stakeholders. So some of these big sort of national global scale challenges, there's a lot of stakeholders. And so if you look at wildfire, for example, obviously the damage is terrible, right? Like these are catastrophic events at a financial level, at an enterprise level, at a personal level. These are catastrophic events. But because there are a lot of stakeholders and there are a lot of different budgets, it's not always clear who the initial customer is and where you can get adoption. That's why I was saying at the beginning for Pano, it's like, oh, wildfires are a big problem. How big is that commercial opportunity and who are the buyers would be an initial question. And so you guys are focused on firefighting departments. Pano got started with utilities and landowners because those are the people who have capital, and large landowners, large private landowners, so like ski resorts or others. And because these are people that have very strong economic incentive to stop wildfires on their land. Utilities, it's obvious, they're getting blamed for every major wildfire. The risk, the risk management is like an enormous problem for them. And then the same thing for large private landowners. They have incredible economic incentive to stop those wildfires. So like the challenge with some of these big macro problems is identifying the person with the money, right? Because you need a revenue producing customer, and the urgency, the strong need, not just a, hey, that would be good if we did it, but a strong urgent need to adopt something new. Because if you're a startup, you're bringing something new to market, right? You think it's radically better than what exists in the market. Sometimes it's like a drop-in replacement for something. You have an obvious buyer. You come in and you say it's 10x better, 10x cheaper. Hopefully you'll get adopted. But sometimes it's like brand new. So you have to figure out who has an urgent problem that will take the risk. On a startup, right? You know, like, will you guys be around in 5 years? That's a big incumbent question will be, oh, is the startup even going to be there? And then it's also disruptive to the way I do things today. That's the whole point. That's the whole point that you guys are doing, right? I'm going to make things better by disrupting. But then for them to take that risk, they have to have an urgent problem. It can't just be, oh, this would be good if I did it better. It has to be an urgent problem that they have. And that's why, you know, when I had mentioned data centers as sort of as a big macro, that's part of the reason that data centers are being used as the wedge to drive grid upgrades, to drive new power electronics, grid connection, solid state transformers, to do like new power distribution, because they have a critical problem and they will pay to upgrade all this infrastructure that we've wanted to do for decades, right? But they're the sort of urgent hair on fire problem that will pay for these upgrades. And I'm not saying they're the only one, because there's much bigger problems than just, there's other big problems, but you have to find somebody that has that kind of urgency.
Thank you.
Awesome. And with that, I'm going to leave us into the break, but I did want to put up the last slide. Oh, I don't know. I did want to put up the last slide just to say again, to remind and inspire all of you that the opportunities are massive here. And they're big industries, so the opportunity to deliver impact, both sort of in a global wellness scale, but also financial, is enormous. So look forward to working with all of you as you bring these solutions to market.
Thank you so much. Okay, now we're going to go into a short coffee break. So we're going to come back at 11:10. If everyone can just, feel free to wander out. Thank you.
I just want to see what the clicker looks like.
Right.
Yeah, because I didn't. Did you come early? No,
No,
it's just
no,
this
no.
to go forward and then. Yeah. Get back high soon. Well, I should probably ask.
Data goes straight to her.
Yeah. Like grab like the, I think that could be like or like.
That's what I.
Oh, like, I think it's this one. Yeah. But like the data research. Oh, for sure. Because yes, yeah. Oh, this was no, that. I know. No. So we're gonna be like very late. Yeah, it's not a good. No, it's okay. It's okay. Maybe they didn't have like the lights version. The first one I had was like the 80%. Okay. Yeah. 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 We're looking at what else is in draft that's like more wide. Yeah. I'm so much fun. Yeah, it's a yeah. Perfect. Yeah. We can just yeah.
Yeah, okay. I just like different.
Okay, if everyone can start taking their seats again, we're going to get started in a minute. Okay, great. Thank you. So now we're up for our second block of startups. So we've got 4 on deck for you now. And first up will be Mineralize.
They're both working? Yes. Okay, so good morning, everybody. I'm very excited to be here. I'm Rafa. This is Aiki, and we're part of Mineralize. We're also joined by Wendy, and we have one of our co-founders on the Zoom link. So just want to start by playing a quick video. I think we talked about a lot about fires today, but we're going to talk about another threat that's putting infrastructure at risk, which is water and coastal erosion. These images were shooted not far away from here, the Cape Cod, but this is a problem that's global, affects billions of people in some islands in the Pacific. People are risk losing their lives and their houses because of erosion. So we developed at Mineralize a solution that strengthens sand using electricity in a way that slows and mitigates erosion. Our goal is to provide to our customers a way they can just forget about these issues. So just clicking here, go of the numbers, it's a problem that affects 40% of the global population that lives within 100 kilometers of the coastlines. That represents 60,000 miles that is at risk currently. That's 1/3 of the coast of the Earth. And that has an estimated losses of over $14.2 trillion up to the end of the century, with a total addressable market of $15 billion per year. Yet, the current solutions that we have available are either too costly, not environmental compatible, or impermanent. So I just want to talk about 2 of them, and they're done by a bunch of different companies. So one of them is seawalls, which essentially consists, that's like the middle one here on the slide, consists of like stacking up a bunch of rocks to prevent erosion. And that not only causes a lot of damage to the ecosystem, but also increases erosion in the surroundings. And quite frankly, when you talk to people, they mention it's an ugly solution. Another one that I have here is beach nourishment, which consists of using sacrificial sand. So one of my interviews that I did with customers, they related they've paid over $200,000 in sand just to watch the sand being washed away the next day. So we can do better. We did over 51 structure interviews, talked to probably more than 100 people, homeowners, people in the construction industry, regulators, should come to the conclusion that the market wants a better solution, and we've built that solution.
And we have created a bio-inspired solution that mimics how marine organisms build their shells to create calcified substrate to protect themselves. Instead of metabolism, we use electrical energy to mineralize coastlines using naturally occurring chemistry. The process is quiet, cost-effective, and fully reversible if needed to be. And the process starts instantaneously and works everywhere, provided that 3 essential components are present. The 3 simple components of our technology for which we have developed a patent are a pair of electrodes, such as cathodic mesh or anodic rod, and solar or generator-powered electricity, and lastly, mineral-rich water or seawater, to put it simply. And when embedding the electrodes into eroding soil, what happens is with electricity, naturally dissolved minerals, for example, calcium or magnesium ions, precipitate in the form of durable solid. And the solid minerals like calcium carbonate and magnesium hydroxide are formed, which act as a glue, bind the existing soil particles and convert the initially eroding material into a strengthened and porous substrate, and all of which is achieved while allowing for water transfer to the beach from the treated area, therefore maintaining the marine ecosystem as well. And this slide, which is my favorite, shows the operation of a technology in a coastal environment. From the top left to right, you see how our cathodic mesh are installed along the slope of an eroding bank. Once connected to the power source on the bottom left, our electrochemical treatment process initiates immediately. And over the treatment period, the soil particles surrounding the cathode turn into a substrate that seamlessly integrates with the underlying sand. And our flexible cathodic mesh can be fabricated with wide apertures, meaning that the resulting substrate is strong enough to withstand wave energy while remaining porous enough to allow water and sand migration between the sand and beaches and support the growth of native vegetation, and which helps preserve the natural character and habitat value of the coastal environment.
Yeah, I really like this slide. It's much more about not only coastal protection, but it's coastal healing. It's restoring this to the regional state to some extent. So our offer is transformational for a couple of reasons. Is in terms of price compatible to everything that is offered in the market over a 50-year lifespan. That's usually like the traditional how long those infrastructures will be existing. It's the only permanent solution that it's also environmental compatible and restores the vegetation back to the original state. On top of that, we also want our customers to forget about coastal erosion. That's why we're offering this as a service that takes care of everything from the size assessment, the engineering design, the permanent management to allow the projects to start, the project installation, and the long-term monitoring. In terms of the business model, what we're trying to have here is a revenue flow that starts with a 30% of the total amount of the project for the first 3 phases, and then 70% as we start installing the projects, 30% up when we start and 40% at the end. But also a service as we can develop this long-term monitoring system that using the technology that we deployed, we can make sure that the coastal is not getting eroded, and if needed, intervene. In terms of the costing, we are offering something around $1,500 per feet of the shoreline, and the long-term service would be $1 per foot per month for this optional monitoring service. So even though we're starting with coastal erosion, this technology can be used in different other applications. One that I like, for example, is sand dune stabilization. That's going to be our goal in the long term. In terms of their go-to-market strategy, we are starting with private homeowners, including hotels in the short term, because that's like the shorter sales cycle, and also it's a way of scaling, testing of technology. Our medium term is to go for contracts with the government, where most of the market opportunity is to help protect infrastructure, and the long term, we want to license the technology and make sure that we are not scaling the team as for more than you needed. This year, we are starting our first pilot in the state of Massachusetts, and also we're having active conversations with homeowners in the Pacific Coast, Oregon, and we just had a very good call with a homeowner yesterday to start a pilot in California. So demand is here. We have demonstrated traction. We're going to start hopefully our first pilot this year, and have active conversations with homeowners, and also a pipeline of people who would be interested in having that technology deployed at their homes. The MIT Prize Fund would be extremely important for us for a couple of reasons. So first, that would bridge our initial expenses to cover for the pilot, would also allow for additional lab testings, including this environmental restoration testing. That would be fundamental. And also would allow us to start developing our proprietary monitoring system as part of our solution. Lastly, solving coastal erosion, it's a real demand problem. That's why we have a team that have different expertises combined. I'm taking care of most of the business side as a MBA Kellogg student, working at McKinsey. Daiki is doing the PhD at Northwestern in the area. We also have Lissandro, who is a serious entrepreneur person that is the venture behind it, and also Wendy, who will join us for questions, that brings over 30 years of expertise in the legal system, but also a sense of urgency as she is personally affected by coastal erosion. So I want to say that erosion is a tax in our future, and we believe that we can solve it if we mineralize the shorelines. Thank you. Also, before questions, we brought some samples from the lab that we want to pass to the judges. Yeah. So that's the final result. That's that we got.
Thanks, guys. So I think the climate adaptation piece is very obvious. What I'm interested in is there also a decarbonization aspect to this? Like, is it the embodied carbon of a concrete mixture, or how do you think about that aspect?
Yeah, I mean, there is. If you compare to the current solutions, we're not using cement. We are using things that are local. So of course, there's the transport element, and for other of when we scale this up, instead of using those like cements, like super carbon intensive solutions, we could also tap into that area. That's not our initial focus, but yes, that's also part of the.
Have you put any estimate numbers to that about how many tons of CO2 equivalent you think that might add up to?
We did for one of our applications we made. I don't have the numbers in mind, but I can follow this up. But we made that calculation.
Okay.
Is it a once in a lifetime treatment, or do you need to keep the installation up and running?
So yes, it's a once in a lifetime. That's one of the things that's different about it versus all of the other solutions, which either erode, biodegrade, or just wash away. So the concept is you do it once. The monitoring is there in case there's a massive storm, a piece of it cracks. Because you saw it, you have it in front of you, it actually, to a small degree, erodes itself, which is one of the things that sounds crazy, but it's actually additive. There's a sand shortage, and so we are actually growing sand. And so as that happens, if there's a need to basically turn the electricity back on again, it's super easy to do. It just heals wherever the cracks are or can continue to generate the substrate.
To add a little bit, once the cement, once the strength sand is mature, even if the power is off, the sand stays there like this, and no worry about turning it back on. Just in case there's some damage, yeah, we can turn it back on, but basically it's permanent, once in a lifetime solution.
I'm going to ask a really ignorant question, but hopefully it leads to a better question afterwards, which is, so how does this get deployed? You turn up at a place, you just put this mesh of metal down. I assume it has to be embedded actually in the sand for this to make sense. So just firstly curious on how that actually looks physically for you to do it. And then building off that, you kind of had a $1,500 per square foot, right? I'm just curious, what's the major drivers of that? Because that seems quite significant in your benchmarking study.
So I can speak to the first part. It depends on where you're installing it. If you're installing it, for instance, where I live, what would happen is we have coir logs already, but they biodegrade, and they're very expensive to put in initially. So these meshes, like what was shown in the images, it's like a sandwich. You put down a layer of sand, you put down the mesh, and you put down another layer of sand, irrigate it with salt water because we are not fully submerged where I live in salt water, and then the electricity gets turned on and the process begins. If you were installing it somewhere else, like in California, where anyone who's from there knows how houses, hotels, etc., are perched on the cliff, the cliffs themselves are fully submerged, so you wouldn't need the sand. You would just install the mesh, connect it to the power source, and the calcification would begin. And then from a price point.
Yeah, what was the second question? Sorry, just to make sure I'm answering.
How does this all link into the $1,500 per square foot? As in, what drives that number?
Yeah, we have a backup here, but I can tell that most of that's like the full embedded solution. That's like before adding our margin, so that's like the final price for customers. But the biggest driver of cost initially that we're seeing is the pre-design phase, the engineering phase, the permitting. And then the materials that we're using, they're not actually very expensive. And then it's a labor component of someone going there and installing. And it's as we scale, right? Because we're talking about homeowners at first, that cost would just like go down as we target larger infrastructure, if that answers your question. Yeah.
Little clarification question. I thought it was per linear foot of coastline, the 1,500. Is it actually per square foot?
No, it's per linear foot. That's how the industry talks. But yeah,
Okay.
yeah, we are assuming an average, height for that of the 10 feet. But that's how the industry benchmarks itself.
Let's move into power requirements for a moment. So you were talking about, milliamps per centimeter squared. Let's translate that into a typical like beachfront for a home. Is this power where you're going to need to bring in a power source from offsite? Can you connect to the home's power? Like, how do you think about this?
Yeah.
So you can connect to the home's power, depending on how much power is in the house. What we did we were going to anyway install solar. It's a couple of panels worth of solar energy. It could be a generator. We're trying to be silent, so we're not using a generator, but it's just to give you a sense, it's 2 to 4 volts of energy that's being pulsed through. So it's what a house could produce.
Yeah, what's the total current on that voltage?
12 milliamperes. Sorry. Total current, it's like a couple milliamperes.
Oh, the current is in the order of like milliampere actually.
On the whole mesh for
a total current might be like 10 ampere something, but if you divide it by the like active surface area of the cathode, which really like drives the chemical reaction, electrochemical reaction, but so it's not like dangerous or harmful to the environment and human.
Yeah, got it. And then with the saltwater irrigation, just again on this operating mode, is that a thing that you do once, or do you have to do that repeatedly to keep this reaction going?
It's better to be done periodically so that the sand it doesn't have to fully, but partially saturated all the time.
Got it. Thank you.
While it's getting to that phase, once it gets to that, you don't need it anymore.
Yeah, and then total time. So is it like days, weeks, months?
So for reference, this one in front of you, it took a couple of months actually. But depending on the customer's needs, we can like speed up the process, maybe by increasing salt concentration or using the electric grid that gives more like constant power supply.
Yeah. And if you think about like the way erosion happens, that 3 months in a period where it usually happens in during winter, for example, it makes a lot of sense that that's the time that people can bear to wait 2 to 3 months to get that ready in the summer, so that when the erosion season comes, they're actually protected.
Can you share anything about the mechanical properties or what you've found so far? I imagine in this kind of application, compression fatigue become pretty important for those on the edge, but what are you finding now relative to what it needs to be?
Mechanical properties, we have tested like a compressive strength, and which is as high as like concrete compressive strength, actually like 20 megapascal on the order. So mechanical performance wise, we're good. And then also we have seen lower permeability as well, which indicates like how solidified the treated sand is.
Yeah, it's over like 7 megapascal of like, that's what I have tested.
Is it possible to provide a complementary answer remotely?
Lower permeability at this stage, as you think about runoff and other sort of ways in which the natural ecological system operates?
That's one of the things that I want to, you're talking about like the environmental compatibility, right? Like how it's going to affect.
Once you had to have like essentially what is a concrete wall post calcification on the side here, how do you think about,
So
the natural system around it?
we've actually worked really hard, and we're required to because we're starting permitting in Massachusetts, which is one of the 2 most difficult states to get this kind of permit. So we're addressing that in 2 different ways. One is it looks like concrete, which is a problem in Massachusetts, but it actually isn't in the sense that it's porous. And that's why Daiki was speaking to the ability for both the sand and the water to flow between the habitat and the sand. It's critical. We will not get permitting without that. And we're a month away from permits, so we're very confident in that. And also the way we're designing it with the apertures to be able to put beach grass in, we're trying not just to be a wall, but to actually be additive and restore to what was there. The other thing we're doing, which is if you look at like a wall or a coir log, they end dramatically, but we're able to design this so that the apertures sort of taper off in size at the edges and at the toe of the bank. And that should, we believe, and it's been, that's what we're testing, but that should significantly minimize end scour and the end erosion that you're talking about.
How many sites have you already deployed, and what are the key risks you anticipate from there to scale the company?
So I'll let you do risks, but we haven't deployed anywhere. We are about to deploy in Massachusetts. We're starting with 2 very small, like 10 linear feet sites just to optimize the prototype. And then we have 9 customers who have indicated intent to scale up, which we hope will happen before the winter of 2027. And then as Rafa mentioned, we have several owners of Coastline in California who have indicated that they want to implement, and also a property in Oregon. So nothing yet, but we expect by the end of this year to have, I would say, upwards of 20.
Yeah, and very quick because I think we're running out of time here. And that was without almost no marketing, just like people that are, find the solution. But I think 2 big risks. So one is the regulation. That's why we're working very hard with in one of the hardest states to get the permit, Massachusetts, to make sure that we are meeting all the requirements. That's going to be done by state, so it's going to take some time. And the second risk, of course, there's like all the technological risk, right? We want to make sure that the environmental compatibility piece is working, and we're bringing back the vegetation. So those are things that we need to should still test as we scale. But the demand is there, and we are trying to bid the market. Okay, thank you.
Thank you. And next up will be Osyta. You want to come up?
Thank you. Hi, everyone. Good morning. My name is Osyta, and I'm the CEO of Osyta. We're building an AI-native carbon tariff engine. In 2026, the European Union introduced a carbon border adjustment mechanism, essentially applying a tariff based on the carbon intensity of goods coming into the European Union, specifically for iron and steel, aluminum, electricity, hydrogen, and fertilizer. Yet most emerging market exporters lack the digital infrastructure needed to meet these requirements efficiently. And they're relying on manual consultants such as EY, Deloitte, to reconcile all of these multimodal data sets and turn them into the final CBAM registry data set that they need, which is an XML file and an Excel file. This is expensive and this is slow. That's why we're building Osyta. Osyta is a CBAM ingestion engine. So we're taking all of these raw multimodal data, PDFs, Excel files, meter data, and then we're turning it into that final output that's needed. We're also going to build verification rails, partnering with these with our clients to make sure that they get verified the next year. And then eventually we want to tack into the importer side of things, also serving these clients and being an end-to-end CBAM compliance platform. This is a pretty slide. This is our value proposition. Before, we have this messy ecosystem for CBAM, which includes consultants, which includes a lot of negotiation, which includes a lot of value loss. And for us, we're going to be that central node that's going to connect all of these pieces together. This is a demo this is a snapshot of our UI, and we're currently using Gemini and we're using Claude. So Gemini has the best image recognition model, so it's able to actually read these production logs. And then we're using Claude to build a chatbot, which is going to replace these consultants in terms of actually trying to find out what data they're missing And we're also using Boundary, which is a programming language that's specifically made for building AI agents. And the reason that we're using this is because we're working in compliance and our LLM can never make a mistake. And by using Boundary, we're actually going to make sure that our AI is never going to make a mistake in terms of getting that final output ready. On our just to really hash over and make sure we're going over what the product is, we're turning these inputs where they show the production logs, the scans, and also in all the different languages. We're using OCR extraction. We're going to normalize that data, and then we're going to validate it, and then we're going to have the final output, which is the Excel and the XML file. We're delivering value for all of our stakeholders, which include the exporters, the importers, and of course, climate impact. We're providing climate impact by accelerating decarbonization in making trade decisions. And for exporters, we're going to be slashing the time that it costs to report. And for importers, we're going to be lowering their liability costs for CBAM. And just on a personal note, why I was brought to this space is, so I'm Dutch and Nigerian. And so I'm very passionate about climate impact and of course like international climate policy, but I'm also really worried about the way that the West and the European Union has decided to implement all of these international climate tariffs because of the impact on the emerging markets. Everybody knows that industrialization is the path for global development, and but just CBAM by itself is projected to impact the African GDP, contract African GDP by 1.1%. 70% of the world's poor who live in destitute poverty live on the African continent, and this is shameful. In terms of the tailwinds that are coming up for CBAM, in 2027, they're going to include indirect emissions. In 2028, there's going to be sector expansion, which is going to include ceramics and plastics. And in 2030, there's going to be, the CBAM is supposed to be well established, which means it's going to include the entire price of the European trading system, which is currently at around 80 euros per ton of carbon. And by 2034, it's going to include every single sector that's currently included under CBAM, which includes oil and gas and paper and pulp. And there's also going to be a knock-on domino effect with CBAM. So the UK is also is projected to implement its own CBAM in 2028. And currently Australia, the UK, Canada are all also predicted to implement a CBAM over the next 10 years. We actually signed our first our first LOI for our pilot program yesterday with AVB, which is this Brazilian steel company. And we've had calls with Sonaseed, which is a Moroccan steel company, with Fertiglobe, which is an Abu Dhabi national oil company, and Sisma, which is a Turkish cement producer. And we've just been doing this through founder-led sales. So my co-founder and I have sent thousands of emails to all of these different companies. And eventually we also want to build a brand. We want to try to get inbound sales by doing things like this, by doing the MIT Climate and Energy Prize and participating in these accelerator programs. And only once we've found product market fit are we going to really accelerate by hiring a VP sales and getting started. We're making our business model hinges on two revenue streams. So one is this ingestion engine, as I mentioned, which is through a SaaS model. So we're going to charge per ton of carbon that's going into the European Union, just so that we have a mechanical way to actually price our product and like build credibility. And but for a huge client such as Fertiglobe, as I previously mentioned, we're expecting to make around $100,000 of revenue when we're dramatically undercutting them having to work with UI or one of our other competitors. And then verification brokerage, we're going to take 20% of the verification costs, which we're going to coordinate with these third-party accredited verifiers. And then future revenue streams is we're thinking about also doing verified abatement with carbon credits, but I do really want to iterate here that our product is a must-have and it's a compliance-driven product. And this carbon credits revenue stream is only an additional thing that we could eventually layer on and building lots of different revenue streams for our product. What I find really exciting about our business is that we're in a massively growing TAM. The TAM for our product in 2022 was 0. The TAM for our product today is around $100 million. The TAM for our product in 2030 will be $3 billion. And the TAM for our product in 2034 will be $10 billion. And that's this TAM expansion is hinges on 3 different axes, which is the sector expansion, as I previously mentioned, because of the EU continuously expanding what's actually covered under CBAM, but also an ARPU lift, which will come from the price of carbon coming up. And and from these new revenue streams that I mentioned, and also the multi-jurisdiction rollout with the UK and with Australia, and eventually all these other countries joining and erecting their own carbon tariffs. So we're positioning ourselves and we're differentiating ourselves across two key axes, which is we're serving emerging markets and we're also AI native. And I know this term AI native is being thrown around a lot recently, and I think I really want to make it clear that our use of AI is critical to being able to serve emerging markets. Our competitors have also used this term AI native and in a pretty meaningless way. And the reason that I say this is because when we're reading production logs, those messy production logs only exist for our clients, which are emerging market exporters. So our emerging market exporters, they have thousands of pages of these production logs, which are sometimes handwritten, and our models are able to read and go through these production logs and then transform them into that final XML data set. And I also would like to make the point clear that our clients are criminally underserved. So all of these big SaaS providers, such as Carbon Chain, the moment CBAM was introduced, of course, rushed to build a product for in this space, but totally neglected the agency of emerging market exporters who want to also become CBAM compliant. Instead, chasing the easy money, which is the importers who actually pay CBAM, but it's the exporters that want to become CBAM compliant to make their good more competitive. Our pilot proposal is we're working with 2024 to 2025 data. So we've asked our clients to send us their PDFs and their meter data, and then we're going to batch that data ourselves before we actually roll out our product. And as I mentioned, we signed our first LOI yesterday. This is our team. This is my co-founder, Friyang, who I met at Goldman Sachs. We were working in IB and natural resources, which is where we got our first introduction to this space of natural resources. We were banking chemical companies. And my CTO is my cousin, Eloah Salami, who's an AI and math major at the University of Pennsylvania. And we currently have an advisory board, which is Shalmoy Bergamov, who I read the paper on CBAM and who was the first sort of spark where I got this idea to go and build out this product, and Alexander Clark, who is a data scientist at Airbnb. We're raising $1 million at a $10 million cap. And we need this to grow fast and to build our product, and our main cost is going to be in customer acquisition costs in terms of actually closing these sales cycles. Sales cycles have been kind of slow. And yeah, thank you. And if any investors would be interested in speaking, we'd love to talk, of course. Thank you.
Thanks. So first question is really around the human not being in the loop. I wonder if that's going to be a challenge or friction for adoption because of the accountability piece.
Yeah.
So I think the vague question is, how are you going to assure your customers that the mistakes won't be made? And are you pricing into your business model that you'll cover them if mistakes are made?
Yeah. So there is a human in the loop in terms of how the product actually works, because all of these companies do have ESG teams and HSE teams, but they don't know how to get that XML file all the way through themselves, and that's why they're working with the clients. And in terms of making sure that the AI model never makes a mistake, I've built in a bunch of layers of invariant of logic that has to be true to make sure that the AI model has correctly picked up the right number. So for example, in a production log, the number has to be greater than 0. You can't read a negative number. And by layering in these invariants that have to be true, you can with statistical certainty be sure that the AI model is every value that it said is correct, and all the numbers that it said is wrong are going to be fed into the human for the human in the loop to review the workflow that's taken place.
When you do this for an emerging market importer, you've talked about them at a bunch of different levels of sophistication. You've said they have ESG teams, but also all they have is paper.
Yeah.
Give me a picture of what that commercial engagement looks like, who you talk to, how you close that sale, and then how you retain that customer.
It's looked really different. So our clients are at the moment basically any industrial producer who's not in the EU. So of course there's a really vast range of who we've spoken to. We've mostly been speaking to ESG teams at these industrial production companies. And the reason that some of these production logs are handwritten is because it's not the ESG teams that are handwriting the production logs, it's like the operational managers. Yeah. Could you clarify your question a little bit more?
Yeah, absolutely. Just the idea being like, walk me through a sale. So who are the stakeholders? How do you get them on board? What do you do for each of them? And then how do you keep them?
We have been doing outbound sales to CEOs. So we're just sending a lot of cold emails, and then they put us into contact with their ESG teams, and then we coordinate with their ESG teams. We send them a link to like a doc send. They send us in batch all of their PDFs, and then we're batching that data ourselves at the moment. But eventually what we want to have is, of course, just like we want to scale. So we want it to be our product to be hosted, and for them to be able to sign up, and yeah.
And maybe to follow up on this type of question, are you more focusing your outbounds on exporter to EU or from importers in the EU?
So we are focusing on exporters into the EU. And eventually, to capture the full TAM, we do want to serve importers, but I think we really want to own that workflow that's outside of the European Union, because that is where the data lies. And that's also how we're differentiating ourselves from our competitors.
I'd also like to add that, you know, for a lot of these exporters, this is something, again, it's really mandatory for them to have this. It's not a nice to have. It's not something where, oh, they feel like it's socially good to participate in this. If they don't have the correct compliance, whether it be for CBAM in the EU, but also for other jurisdictions that are coming online in the next couple of years, they get pushed to the highest level of the carbon tariff, which makes their products uneconomic to sell and makes them not competitive. And so for them, this is something that, because they don't have the digital infrastructure right now, we've seen a lot of traction and a lot of interest because of the fact that we can be there on the ground floor and help them, you know, integrate into this digital ecosystem and be their defaults.
So what would stop, say, you said like a carbon chain just going after this as well? Like, I'm just curious how you view the like long-term defensibility of your position. You know, they're going after the logical market right now, and you're kind of positioning yourself elsewhere. What would stop them doing that? Or a new entrant that also says, I'm AI native, mock something up in Claude and go fast.
That's why we need the capital. Like we need to run with this really fast, and we need to make sure that we're the leader in this space. Candidly, the technical moat for this is quite low. I'm an economics major. I vibe coded this over the winter break. So it's a really valid question, and that's why we need this capital to build out our product, to make it production ready, and to win.
Do you have a good sense of what other tools that the exporters are using as they meet other requirements beyond CBAM for having market access? And, you know, if you have a good sense of what those are, you know, is this another tool that they have alongside of it, or are you looking to be able to integrate into their existing workflow?
Yeah, so they're using the traditional ERPs, and we want to integrate with those tools as well. But those ERPs they're using that data and then just relying on the consultants, to be able to get them CBAM compliant.
Yeah, maybe the last one is, how do you sort of think about your role in ensuring that they are compliant as the data orchestration and like tool to help make that more simple versus the verification piece of it? And if you're like, we talked maybe a little bit about this yesterday, if Ernst & Young is kind of like the third party that becomes the, you know, hey, the board blessed that this is actually okay, you know, the risk is no longer ours. How do you think about your role versus orchestration versus verification?
Yeah. So the verification piece is just coordination. So when a Nigerian cement producer has submitted a file for the CBAM registry, the following year they have to get verified, but there is no European Union accredited verification company in Nigeria. So that means that they're going to have to find and coordinate with one of these verification companies in Europe and negotiate quotes and you know, actually find a verification company that wants to work with them, right? Because not every European country wants to go to all of these markets and actually engage in business with them. So what our piece in that verification is just coordinating engagement and being able to find accredited verifiers who will work with them and like negotiating that price. And then in terms of the measurement reporting side, that's us actually doing the work for them.
Could you elaborate what a deployment at a customer level means? What type of data are collected? Who is providing this data? How long does it take to ingest this data in the system and to make these reports?
So our product, you'll probably be able to do an iteration and getting CBAM compliant within a couple of hours. So compared to a couple of months with relying on a consultant. It's really just a question of dragging and dropping PDFs into an LLM. Yeah.
Again, coming in with a late question. When you think about the major pain points that your customers are facing, is this one the bottleneck, or is it just one in a series? Like, if you do this thing, are they unlocked, or are there more things they have to do?
It depends on which customer we're talking about. So in terms of who we're focusing our wedge on, which are the emerging market exporters, the bottleneck is in the transformation of the raw plant files into the XML file that's going to be submitted to the European Union. And in terms of the bottleneck for the importers, it's actually making sure that the data that they're using and that they're paying their tariff on is correct. Because if that number isn't correct, like an EU watchdog is going to come after them and sue them to the ground. For the verification side of things, the pain point is actually just being able to find a client. So there are multiple bottlenecks and there are multiple pain points, but that first bottleneck that we're really working on is just being able to, in an automated manner, turn raw plant files into the final data that needs to be submitted to the European Union.
Thank you. Wonderful. Okay, next up is Lid G3D.
Hello, test. Okay, I'm gonna say real quick, our company is called Lidge 3D, and that actually stands for Light Initiated Direct Growth 3D. Okay, so I want you guys to think about electronic waste right now. So I think everybody in this room, from what I've seen, has a smartphone, a laptop, maybe some tablet device. And so really, we ultimately get new ones, right? Not because they're broken, but maybe because we need to update them, or the software needs some new product to bring it to light. And now think about that globally. How many people do that? And so that brings us to the problem that we generate 300 million tons of metal waste each year. And it doesn't stop there. It actually continues on to our powder-based metal manufacturing methods, where currently we're mining the ore, we're refining the ore, we're sending that through atomization and production to get to a size that we can use, and then we're throwing it in our manufacturing. And the manufacturing processes are very high energy, high temperature processes. And ultimately, these lead to high energy costs and CO2 emissions. They are also incredibly wasteful processes because they use metal powder. They're slow and inflexible. They do not have a lot of customization, and they're very slow printing speeds. And finally, the sustainability bottleneck. This is not a very recyclable process for metal. And so when we think about this, we've been doing almost the same thing for 300 years since the Industrial Revolution. We mine the earth for metal, and then we melt it. Even our additive manufacturing technologies now, we're still melting. And that's where our solution comes in. we're going to think about the next generation of metal additive manufacturing. And so our solution is a powderless metal 3D printing technology. So we use light as a dynamic mold to volumetrically print metal objects within minutes. So instead of using high-cost metal powders, we integrate low-cost metal salts into a printing solution that we can print at speeds that are 100 times faster than conventional 3D printing technologies. Furthermore, we can extend this to volumetric 3D printing to improve our speed by even 1,000 times faster. And we can take things like copper waste and turn that into a functional metal part. Also stainless steel as well at cheaper value. And so this is a fully circular metal 3D printing approach. We're trying to rethink the wheel right now. So we can take our metal salt printing solution, integrate it into our 3D printing process, make a useful metal part out of that, and then once it becomes waste, it can go back into the metal 3D printing process to be born again. And so with this technology, we're looking to lower global CO2 emissions by 90%, the overall energy consumption by 70%, and have 100% recyclable materials, generating a global climate impact at scale. And so why do we need this? So metal manufacturing is only growing, and there's more of a need for multi-metal parts where maybe an alloy or metal alone cannot serve the needs of the customer. Also, again, we live in the 21st century. Our energy costs are going up, and our dependency on electronics is only increasing. And furthermore, we need these faster. We're trying to eliminate the steps associated with metal manufacturing. And so this is a $14 billion industry in 2026, and it's going to grow by 30% in the next 10 years. And so for micro scale, so we're looking at micro scale metal parts, and if you account for that, that's still about $5 billion of the total industry. And so how are we going to have our business model? So we're going to start out as a custom service. So we're going to have customers give us digital models and print their customized metal part within the first 1 to 2 years. Then we're going to go into product commercialization, where we're going to have multiple Lidge 3D printers that can print small scale customized metal parts at a bigger production value. And then finally, we're going to go to factory size manufacturing, where we can produce almost around 10,000 parts per day on a global scale. And so our commercial roadmap, we're going to start off by having a Gen 1 desktop printer that fits on a lab bench. And we're going to up the production value by adding multi-material or multi-metal capabilities, and also then having that go to a Gen 4 manufacturing platform, which can handle the large-scale productions that our customers need. And so early traction, so we've already demonstrated around 10 or more metals and alloys, and we've also demonstrated multi-material capabilities. And when I say multi-metal, I mean that we can go from copper to nickel to back to copper all in one part. And we've already generated over 150 functional metal parts. And we validated this by participating in things like NSFI Core. We're also talking with pilot customers at this current stage, and also angel investors to invest in our company as well. So who are going to be our first customers? Right now, we're looking at biomedical devices such as customizable stents. We're also looking at thermal cooling devices where we can generate geometries that are much more optimized to handle thermal loads at a fraction of the price. And also things like telecommunication waveguides. These are very important, and their initial cost is around $2,000, and we can lower that to around maybe $10 per part. But it doesn't end there. We actually can go into industrial tooling. We can go into aerospace as well for customizable injector tips, and also into fashion. So things like jewelry, where people need this kind of multi-metal between silver and other metals to make fashionable product. And so how are we going to compete with what's on the market right now? Lidge 3D is going to be the only sustainable powderless multi-metal 3D printing method on the market. And in addition to this, we're also going to offer the lowest price, and it's going to be the fastest 3D printer on the market. And so now let me introduce you to the team. My name's Dylan Geralman. I'm the CEO and co-founder, and I'm joined by Dr. Cindy Lee, who is my CTO. And between us, we have over 10 years of additive manufacturing experience. We're also supported by a team of highly successful engineers and scientists ranging from computer software to material processing and also marketing as well. And so what are we asking for now? So we're really asking for $2 million during the pre-seed phase so that we can build our prototype and also expand our team and have our pilot customers to validate our parts. So really what we're going to be doing in the next 2 years with this is going into a stage where we can have a 3D printer that's capable of meeting the needs of our 21st century customers. And with that, I hope today I just taught you one thing about that we need to think a little bit differently about how we manufacture things if we want to have a sustainable world. And with that, I'm open for questions, and thank you very much.
Thanks, Dylan. Let's talk about the feedstock for a second, the metal juice.
Yeah.
How do you make it? Is it chemical intensive? How much do you have to purify it if it comes from a waste resource? And have you done like the life cycle assessment and included that in your kind of decarbonization?
Yeah, so that's actually something that we're working on. So I'm actually from Arizona. So we're trying to work with some people who work in the copper industry to try to recycle that material. Right now, what we've done is only our parts. So, and what we can see is that because you were asking about how much we have to add or the chemical synthesis, or how clean, I would say you have to add just a few. Compared to everything else that's on the market right now, as far as like making the powder, we just have to add our photocurable resin that works with the light. So that's really what we're just trying to have with our 3D printer. Did that answer your question?
Well, I guess just describe what is the metal juice and how is it made?
What is the metal juice? Yeah, so I think like one of the metal juice that you can think of is that it's metal ions dispersed into a liquid resin. And that's really, so it's the extraction process of getting those ions into that metal juice like you're talking about.
Is that acid intensive?
So there is a little bit of acid, yes.
And do you find, do you need to actually develop the entire 3D printer additive manufacturing machine around the resin itself or the juice once you've kind of made it? Or is that something that can sort of fit into other emerging additive manufacturing, hardware?
So you're asking about like if you can take the juice and use it on something commercial? Yeah, you can, but the thing is that you're going to sacrifice your speed. So you can use your metal juice on commercial light-based printers, except those are very slow compared to ours. So those, getting a little bit more technical, is that those are layer-based, so they have to stack layers, and ours is layerless volumetric, so it's only a few minutes. So theoretically you could, but I don't see the advantage of that.
Is there any very sophisticated geometries that can be achieved with your technology that could not be achieved with more traditional additive manufacturing than 3D printing solutions?
Yeah, so your question's about the geometries, right? Yeah, so actually one of the things that, one of the benefits is that we can reach micro scale resolution down to around a few microns with this technology, whereas laser-based methods, which are the predominant method for making metal right now, is they have very poor resolution on the micro scale. So down to like the geometries, we can make very, foam type structures with intricate lattices and variable gradients in porosity as well.
Let's talk about post-processing for a moment. So you printed this thing in a resin. Do you have to burn it out? Do you have to do any other post-processing steps? to get to net shape?
Yeah, so that's actually, that depends on the customer, but there is a sintering, and like you said, like kicking out the resin, yes, you have to kick that out, and then also the sintering. So it depends on how dense do you want this? Do you want this 99%? Do you want it 80%? So it really depends on the needs of the customer.
And then after that, you have a net shape part.
Say that one.
You have the part in the final shape with the final finish after you've done that sintering step?
Yes.
Can I just ask more a general question? Do any of your customers care that it comes from waste? As in, the 3 pilot companies you had were stents, telecommunications, and data centers. We're all talking on the micron scale here. I don't know, how much of a driver is it for them that this seems like a lot of the pitch was around the waste side, whereas all they're going to care about is purity, precision, everything else around that, less so the waste, particularly for a micron size thing.
Yeah, so I think the one thing is they're looking for cost and speed, right? They're looking for, I want this part right now at a lower price. And the thing is that I think about is that how many times do these companies need to go through like design iterations if they're going to have some kind of part that they want to use for their, you know, circuit boards or anything like that. And really this approach, what we're trying to highlight is that if you want to take your part and just throw it back in, or if you want to decommission a device and make that part again, you can, right? I think of like things that are not useful. Like if you CNC copper, you're left with all of this scrap. What are you going to do with it, right? Well, you can take that scrap, put it in this process, and you can make metal instead of just throwing it back into the earth.
But so the advantage is more on that closed loop within a company itself. Like,
Yeah.
and then you're kind of more confident on what the metal's actually going in, to the question earlier.
Yeah, so I would say also like that also makes us provide a lower cost, right? If it's circular, we can provide lower cost to our customer since we're not generating that much waste as well.
So in that last question, I'm a little confused about the business model. Are you not going to supply the metal juice feedstock to the customers as a recurring revenue, or are you providing the entire system that lets them recycle and close their loop?
No, so we're actually running our business as a manufacturing. So we're not selling the printer, we're not selling the juice. Those are proprietaries to us. And so what we're trying to do is we're trying to find a customer, let's say for thermal management, of we can produce 10,000 of these heat sinks for you in a day.
So you're closing your loop then, not
Yes,
the
yes,
customers. Okay,
exactly.
got it.
And we're also saying if you have some metal in your process and you don't want to use it, give it to us, we can make it into something functional. We're just trying to eliminate the waste that's generated in the metal. And we're also trying to make this, I just want to say, safer, because powder is inherently dangerous and you get a lot of losses by using powder, and you need special equipment, so it really drives your cost. So we're just trying to make it more easy for them to make their part.
Have you tried this in commercial volumetric printers?
No, so this is a, and what do you mean by volumetric?
So things like, I mean, the brand names are escaping me. I guess like Manifest Technologies is one, and
Yes.
there's one that starts with X, whose name I can't
Yeah,
remember.
I actually met with Manifest last week. So, but yes, I would say that ours is kind of, it's home built right now. So it's from my PhD, I've built this volumetric. It's very different from Manifest. It's actually where we get our name, because Lidge actually, it translates in Chinese to growth, like growth of a fruit. And so if you see in that one, we're growing it from the bottom. So where Manifest and other technologies might do side, and they have resolution issues as well. But I'll say lastly, theoretically, when I talked to Bob, he said that he could definitely use our metal juice in his process.
Thank you. Next up is Terra. Terra Compliance.
Last one before lunch. Can we do it? All right. Meet Peter. Peter's been working across the solid waste industry for nearly 40 years on both the public sector, private sector, and has really seen pretty much everything from running facilities like landfills, MRFs, paper plants, you name it. And most recently, he was the executive director of Recycle More, which manage a handful of Northern California cities, ushering their day-to-day solid waste operations and ushering them through California's State Bill 1383 compliance. So in the past, waste reporting wasn't that difficult. Folks like Peter didn't really have to think much about this. He just had to make sure that the waste management companies were doing their job, ushering them through, day-to-day operations and their collections. Today, however, things are much more complicated, and teams are responsible for a ton of new data and Peter's left flying blind, as are many others like him. So why is this? States like California have lofty sustainability goals and have passed regulation to chip away at this climate change. But it's leaving folks like Peter flying blind, as I mentioned. Landfills are the third largest contributor to methane emissions, and it's actually our best chance, one of our best levers at chipping away at near-term warming. But when Peter went out to look for solutions, nothing on the market really got the job done. Him and many others were left cobbling together a bunch of different tools, using legacy systems, Excel spreadsheets, or playing lengthy games of telephone or literal telephone, or paying for thousands of dollars for legacy software where things as simple as resetting your password were taking them up to 8 weeks, which really blew our minds. So laws like SB 1383, though, didn't create this problem. They exposed this long-standing data problem in the solid waste industry. And this is why we built Terra. I'm Emily Lee, and this is what we're after today, is filling that market gap and building the product that Peter has always dreamed of. Terra is the solid waste sort of operating system or compliance hub for these teams. We aggregate the data from solid waste management companies, these cities and municipalities, and their third-party waste consultancies to allow them to have a source of truth to manage their day-to-day operations and also roll up these inputs for their mandated reporting, starting laser-focused on this State Bill 1383, but already expanding from there. So if State Bill 1383, which is the nation's most aggressive organics waste bill, succeeds by its mandated 2027 deadline, that would be equivalent to taking 4 million cars off the roads just in the state of California alone. So as we're already growing into this broader platform play, this is where we really see the impact beginning. And luckily for me, Peter's not a hypothetical character. He's actually on my founding team. The reason that I stumbled into all of this was due to his son, Ethan. Ethan and I used to be former colleagues when we were building blockchain infrastructure products. And he called me up one day after a casual dinner conversation with his dad. His dad was complaining about the nightmare that I just explained and really frustrated by the tools that his team were able to choose from. So Ethan called me up and we started to dig right in. And with the access to Peter's network, we were able to do deep discovery and build the product right alongside potential users, and are still able to leverage Peter's extensive network for go-to-market and sales and product input to date. Our business model is proven and sticky with annual subscription-based SaaS with an average contract vehicle of $35K annually. From here, we see high margins and historically low churn in GovTech space, with contracts ranging from 1 year to 5 year. And an interesting thing is that unlike some other players, we aren't competing with these third-party consultants. We're actually able to leverage them as an extra go-to-market motion, because if we get one of their clients and prove well, we're able to scale to all of them, say another handful or up to another dozen or 20 cities. And where are we now? Terra's been bootstrapped to date, and we've been able to prove out our model and have paid and closed $155K in ARR with about 75K outstanding currently in procurement. Our pipeline right now is 600 to 700K in late stage negotiations or sales conversations, and we're really targeting to close 1 million by the end of this calendar year. So as I stated, we started with SB 1383 and selling into the municipalities and have been able to use those consultants as an additional go-to-market motion. Through those, we've actually been doing additional discovery on what else is out there in the solid waste space, and there's a ton of opportunity. We also have recently signed an SOW with a Fortune 10 Silicon Valley tech company and are continuing to do more discovery in that space, as enterprise might be even a bigger play than what we've started on. So as I've mentioned, we started laser focused on Peter's exact pain point, but have already been learning so much more about where this could go. Just with our SB 1383 alone, we're looking at a $14.5 million market and hoping to expand to additional modules from the customers that we have to date, as we're already seeing them ask for more as we grow into more of a data platform play. And then as mentioned, we're hoping to take this outside of California, not just through municipalities and state mandates, but also on enterprises looking to tackle their problems in solid waste. And we're already seeing this happen. This is actually from a sales call yesterday where Carrie from the city of San Leandro is asking, how can we also tackle things not just even in solid waste, her stormwater, or now that she has this data visibility, how can she think about new initiatives that she was unable to try out before? So piloting things like trash-free restaurant certifications or construction and demolition initiatives as well. Here's a few more of those things and kind of where we stand on them. And one of our key focuses right now is not only making sure our current customers are happy and continuing to sell our initial product line offering, but assessing the willingness to pay across these new modules, as these would increase our ACV without requiring net new sales or cycles. So that brings us to today, where I'm seeking the 100K from this competition to really fuel us across a few different areas. As I mentioned, we've been completely bootstrapped, and we're at a bit of an inflection point, trying to figure out, one, doubling down on the current product and thinking this 100K can take us at least to 8 to 12 more jurisdictions, building out the product to assess those additional willingness to pay modules across 2 to 3 of those, nailing this enterprise pilot that we have with the big tech company, and lastly, a partial sales or customer success hire. So we'd love your support in continuing to turn waste compliance into climate action. Thank you so much.
Great pitch. Can you share a little bit more about like the customer segments? So the municipalities that you're helping with compliance on SB 1383, and then the enterprise tech company. Like I gotta imagine the pain point that you're solving for them is very different from one another. So can you just share a little bit more about what problem you're finding, at least on the enterprise side, and a little bit more about the demo or the work happening with the enterprise customer?
Yes. So yes, they are definitely distinct problem sets. For the municipality, it is mainly around the regulation and reporting requirements and wrangling those pieces of data across the different parties. So often in some of the systems they're working with, they don't even have simple things like roles and permissions. So even giving them that hub to do that and be able to take that out into the field on a mobile or tablet and go back to their desk and have that reporting roll up. So that's kind of the first side. And I know you were asking particularly about enterprise. So they are quite distinct. And the problem that we're solving in this first pilot is, think of the large campuses that a lot of these big tech companies have, or these life science facilities have. They have tons of solid waste services that are being provided to them, but often the data around them or just the monitoring around them is kind of an afterthought, but it's millions and millions of dollars. So for this first one, we're helping them with a lot of their billing right sizing, as it's called. So looking across their campuses and better determining, are there places where they need to up or lower their services, and normalize a lot of that data around that, which then feeds into broader ESG reporting that they have.
Can you describe also what deploying your solution means? What type of data are already collected? And what is the most complex in deployment and what takes most of the time?
Just want to make sure I heard the last part. What takes most of the time?
Yeah, in terms of deployment, is it access to the data, quality of the data, whatever?
Yeah. It's been interesting because some of these folks have felt very burned by previous vendors or some other folks who have come in and tried to solve this. And really right now, we've been mainly starting with just CSV or Excel files from the billing data from these hauling systems. So we do offer integrating with them, but most of them have actually preferred just monthly cadence of providing us these billing services. So that's kind of the foundation data that we use. And it's just ETL of that to get it into our format and then layering on some of these additional inputs. So that might look like what outreach are they doing to compliant or non-compliant businesses, or have any of them had notices of violations or waivers and they're exempt for some reason. That's sort of like layered on top, but the base data is the hauler billing data. And in terms of our process to get that all in, it can happen in a few minutes, but our end-to-end onboarding that we bake in with training and some kickoff calls across these different parties is we budget around 2 to 4 weeks.
You talked about expanding into adjacent spaces, but presumably there's other people making compliance software plays adjacent to you who might expand into your space. How do you think about that sumo match?
That's a good question. So far since we've entered, we've kind of been the new kid on the block, admittedly, and that was definitely something that we overcame in some of the initial sales hurdles and even just trying to get out in industry, doing booths at conferences, things like that. But because it is such more of a, old school market, the trust-based nature of it is super critical, and that's why we've been really fortunate to have folks like Peter on our team and some of the advisors we have in the space. And then just the data platform play itself, like once we have their data onboarded, they're much more comfortable expanding, where they're not really purchasing other software right now for those modules that we've mentioned.
I guess building on that, and maybe a slightly different question is like, I mean, it's impressive you've done this bootstrapping, you've got revenue coming by the end of the year and all this. I mean, what's the kind of ambition for the team? I mean, it sounds like you could build something pretty with light money, that could be a pretty successful small business. But then you kind of presented that bigger TAM opportunity on one of the slides. So I'm just curious how you and the team think about that, if that makes sense. Your own kind of ambitions as the three of you in that landscape. So it's kind of building off Dan's question.
Yeah, I think our ambitions are definitely grander, but right now we are at this inflection point of doing some of this market sizing and discovery on also the timing of these things. As most people know, everyone's like, oh, why would you sell into these things? It's so slow. And we've been able to bootstrap to this date, which has been great and also probably enabled me to stay in school. So now we're trying to assess what is the sort of sequencing where we can still prove out this initial product, but in a way where if we do need to raise or want to raise to go after that bigger thing, like what is the sequencing and why we're really excited about this enterprise offering to get a bit more data around that piece as well.
Congrats on the traction. That you're clearly solving a problem when people are paying for it this early on. As an extension of a previous question, what do you see as the elements of your sustainable competitive advantage in keeping people from coming in and eating your lunch when they see that you've got something going?
Yeah, I think it's kind of similar to what I was saying in terms of one, having sort of these network effects of these relationships that we have and are able to maintain. And especially through that consultant network, we've been able to kind of multiply that across. And then some of the integrations we do with some of the other tech providers is also kind of expanding our reach a bit. And then lastly, becoming more of that, source of truth, not just for this one pain point and doing these additional things for teams. And then lastly, the more data that we're getting coming in is improving our systems and ETL pipelines so that we can handle other data sets where there would be a lot of catch up required because it's quite nuanced.
Got it. Thanks.
What sort of relationship do you have with the haulers? Like the Waste Managements and Republics of the world, how do they sort of see this space and their role in services for the same types of customers? And like, what's your relationship with them?
Our relationship is solid. That was actually the first team that we built the MVP was with Peter and folks from Republic Services.
Yeah.
Initially, the hypothesis was, if you can sell into the private side, that might be a bit faster and better. That hasn't really been the case because some of these cities also have the budget pre-allocated for needing to meet this compliance regulation.
Yeah.
We are still trying to figure out unique ways that we could sell into that side. But really, to date, the onus has sat with the city, and maybe they delegate all of this work to their hauler, but normally the budget and buyer is still sitting at the city side. And for the haulers, it's more they need to do what they say, so we try to make it as easy as possible. But in terms of looking at other things like franchise reporting and stuff, we're trying to get creative of helping solve some of the problems for the hauler reporting as well.
Do you ever see them being competitive at all?
Not to date, because again, it's not really their problem that they want to deal with. The less reporting or, paperwork they can do, the better. So we've been more so helping them do less massaging before they send things to the city effectively.
Got it.
Aside from just raw compliance, what decisions are your customers making based on your platform? And in particular, are they making any purchasing decisions based on the data you're showing them?
To date, it's been more so about the outreach and initiatives that they want to do around this sort of thing. So as I mentioned, some of the outreach campaigns, and that could look like for residential and consumer behavior or on the commercial side. So some of it is still, compliance related as it sits around what other inputs go into that. And then I think the other decisions are kind of similar to what I was saying was happening on the sales call yesterday. It's like, now that they have this data, what can they go after and what can they chip away at that they weren't able to before? So, piloting something at, say, like the farmers market or with restaurants in the local area, or better managing some of their events and capturing that data around that.
Thank you. Okay, we're gonna move into lunch now, and we'll come back for our last block of startups at 1:40. So enjoy.
Hello, you hear me well? Hi, 1, 2, 3, testing. Do you hear me well? All right. Sure, sure.
Uziel, can you hear me?
Hi, yes, I can hear you perfectly. Do you hear me?
Keep on talking, please.
Sure. Well, yeah, I can hear you very well. I could try singing, but it would be kind of awkward. I don't know.
The return audio is plugged in.
Okay. So everyone should be able to hear me in the Q&A.
Just keep on talking. I have to dial you in.
Of course, of course. Yeah, I'm going to read this script so you have like a lot of my voice reproducing. We designed Paragel to be a drop-in replacement for existing logistics. Firefighters will never mix this by hand. For aerial drops, for example, it is batch mixed at the airbase using standard volumetric pumps. A little louder.
That
All right.
big knob, just turn that. It's at the 9 o'clock. Get it to like 10 or 11. Just a little
We
more.
do, yeah. We do not plan to build a $50 million mega
Okay, I
factory.
can raise it during the actual show. I think we're good. So if you do
Okay.
want to speak when Pyrogel is up, I can bring
Mhm.
you into the room, and then there's a lot of people like here talking right now in the room, but I'm pretty sure we will be able to hear you.
All right, all right. Well, perfect then. Thank you very much.
You're welcome. So we'll see you or hear you at 1:40.
Sure. See you.
That's why we're friends. Other spaces are 10. Yeah, I'm really interested in these sides. Right about 5.2, something. And I'm like,
If everyone can start making their way to their seats, we're going to get started in a minute. Okay, thank you guys. I hope you enjoyed your lunch. And we'll have another little break later so you can keep talking. But for now, we're entering our final block of startups. So first up will be Pyrogel. Hello.
In 2024, almost 65,000 wildfires burned more than almost 9 million acres across the US, destroying 4,552 structures and causing over 250 billion in economic losses. And in our regional context in Santa Cruz, Bolivia, on 2024 as well, 9,000 hotspots were nearly 12.6 million hectares. And the destruction devastated almost flora and fauna and causing economic losses of almost 325 million. But here is a hidden pattern. So we have these wildfires going over, but we don't actually have the tools to address and mitigate it. 67% of conventional fire lines fail due to the lack of efficacy rates. So firefighters report applying the gel multiple times, and water evaporates in minutes. And we can even mention that when you apply it like more than 3 times and you leave the gel, it actually becomes more flammable, and it causes the opposite effect after applying. So it's expensive, it's short-lived, and it's polluting because it's ecotoxic. 95% of aerial retardants in the US are ecotoxic. That means that it's not targeting national parks, or it's not, they are not in the market with the government because of the regulations and the PFIs, they cannot enter and protect these areas. There are such a green capital and value for us. And we have heard experiences from firefighters that they say, we need a solution that actually lasts and it's not toxic for our soil. That's why we're presenting Pyrogel. It's a hydrogel network, bio-based, and not toxic at all, that leaves no trace in the soil, and it's more effective than current solutions in the market. This is the chemical mechanisms. First, it releases moisture, so it allows cooling the biomass from the combustion. Then it forms a thermal barrier due to the polymer matrix that reflects the heat, and that's how it allows for it to go below the ignition point. And finally, in our novel breakthrough, it's the intumescence property, which is basically how the gel expands when reacted to high temperatures. So when the peak temperatures are in contact with the gel, it basically allows for it to expand. And this polymer matrix allows to transform into a ceramic-like kind of like cover and shielding the biomass from combustion. So this gel has higher water retention capacity, a high thermal barrier, and it's designed for controlled degradation. It means it's biodegradable partially because it has a mineral phase, that it's not harmful to the soil at all, and it can biodegrade in a month. We have validated traction. We have used the fire dynamic simulator, which is a really well-renowned tool for analyzing the performance of coatings and retardants in the fire retardant industry. And we have proven an emission delay of 335% and a 75 heat transfer reduction. This is only with just 2 millimeters of gel in the biomass. the market is booming. It's big and it's becoming more and more urgent and increasing. In the U.S., it's the global firefighting market. It's about 10.3 billion. And if we were to address and capture 1% of the market, that would be 35 million USD. We are at the top right quadrant, which means that we are prioritizing both the efficiency and the eco-friendliness. We're also considering all the systemic interventions, which means that we are considering all the CO2, all the methane gases blocked, which we can block up to 90%. And we have no microplastics and no phosphates, which means that we're able to address this market of suppression and prevention for natural parks or natural reserves. As I said, it's also biodegradable in terms of the silica minerals, and the mineral it's part of the soil health, so it's not polluting at all. Our business model, it's B2B, and the idea would be B2G, but we're going to start with private because of the different regulations and the time of processing for the regulations in order for the gel to be applied in these spaces. So we're going to start with the insurance market, which is becoming even more and more big, and also commercial forestry, power grids, utilities, private landowners. The market is vast, and we're able to target the need of protecting something that is valued for us, which would be our lands, would be our homes, our infrastructures, or forests, most importantly. So we have 3 types of subscription models. The first one of revenue streams. The first one is, as I said, B2B. The second one is licensing, which means that we would partner with third-party infrastructure or manufacturing companies to produce the gel and then commercialize it. And the third one is basically have this subscription model for private companies that they would basically have a stock of the gel for prevention when the dry season comes. The economic value and the operational efficiency that we're bringing is huge. We have for about 4,000 the cost of production and commercialization, and that protects 1 million in forestry and agricultural assets by a burned low rate. And also public ROI is 1 to 11. The scalability and the risk management is going to be handled with care, because we're conscious that the companies are going to want the gel to be produced massively, and we want to have a huge scale. So that's why we're going to have zero CapEx manufacturing. We're going to partner with third-party manufacturing companies, and for the risking, we're going to make sure to do micropilot tests, which is why we are looking for the funding to do the micropilot tests and prove that the gel is efficient and it's durable and it's not ecotoxic. This is our traction so far. And last February, we've received funding from the EU Global Gateways Program. We've also been in the Swiss Startup Incubator, and we've also had impact validation at Altercom Malaysia. Right now, we have simulation results proving that we have 0 structural damage, 4x ignition delay, and 75 lower heat transfer. Our execution plan in the next months are basically going to be structured in transferring the knowledge that we have on the simulations to lab tests and then pilot tests. With that, our proprietary gel formula is going to become ready for IP processing. And then we're going to focus on scaling and then having a base to produce it. And after that, we're going to focus on the regulations and compliance certifications. that's why with the prize in the MIT competition, we are going to focus on validating the product that is in an early stage development phase and regulations, scale up and manufacturing, and pilot deployments. Our exit strategy is going to be focused on basically being knowledgeable about the big monopoly in fire retardants in companies such as, for example, fire rails or perimeter solutions, which are big corporations, but they are using phosphates and ammonium. And because of their high inefficiency rate, we're actually being better than the big competition because this monopoly focuses on selling high volumes of a gel or a fire retardant that is not effective. And so that costs hundreds and hundreds of millions in aircraft deployment. And so by using our solution that's not needed to reapply the gel like 3 to 5 times, instead of using 5 aircraft, where the governments or private companies are only have to use 1. So that's our team. We come from an international business, material science, and computer science background, and we have many advisors throughout the ClimateKey program, the CAINCO, which is the Chamber of Commerce in Bolivia, and this partnership with the EU Global Gateways program, which we have been able to validate it and to start making traction. This is our anchor point. Many organizations that have been seeing the potential in this early stage phase and helping us throughout the way. Pyrogel doesn't just extinguish fire. It changes the way the world reacts and defends from it. So invest in the future before it turns to ashes. Thank you.
That validate the simulation, or has it all been simulation based?
Yeah, we have used the fire simulator dynamics, which is able to basically see how the gel will perform in a specific degree of temperature with biomass and how the different, like for example, we have the smoke view platform, which is able to see like how basically the temperature in which the gel is between in comparison to the biomass that it's not that the gel is not applied to. But that's the phase we're currently in. Yeah.
But you haven't tested it in real life?
No.
Okay.
It's simulation.
Thank you.
Can you talk to me? I was just getting a bit confused by the markets, the go-to-market, the kind of total potential. And I was confused on 2 fronts. One, you kind of spoke about kind of insurance companies being like early kind of routes there, but then you're also talking about being basically a material, a B2B, a B2G provider. Yeah. And then in addition, you talked about a subscription model, which is, I guess, unusual when you're basically a material provider, be it with you or through a tolling agent. So I'm just, yeah, can you talk me through all of that in terms of who you're selling to, at what stage, at what volumes, and how you see that playing out?
Yeah, of course. So first of all, yeah, we have considered different revenue streams. And in terms of, for example, you mentioned the B2B, which is the first revenue model that we have. And so we would basically sell the gel. We'll start after we get to a significant process in the scale process. We're gonna sell between like 1,000 to like 10,000 batches for the gel to like, we have already like a letter of intent from a startup that's focusing on protecting produce and in the agriculture sector. So we're gonna start small and do the pilot tests there. And in terms of the rest of our business model, we're basically gonna address the market of fire prevention and suppression in terms of, for example, the insurance companies sell services. And so we're gonna provide them with some of the tools so they can then sell it. And in another stream, we're gonna be B2G, which means we're gonna produce. That's gonna be in a later stage, of course, when we're gonna produce massive amounts of badges, and then we're gonna partner with the government to deploy them. Does that answer your question? Could I be more specific?
It mostly does. I'm still confused about the insurance piece. As in, you go to an insurance company, you're like, I'm a materials company, this is what we're making. They're like, okay. I just don't understand their particular involvement with you in that relationship.
Yeah, well, the thought process was the insurance companies are basically selling services of early detection or preparing the properties for climate risks and crisis, right? So one of the revenue streams we've seen and considered was that.
Talking about just the physical reality of this stuff, how do you plan to make it?
Yes. So basically, the normal and manufacturing institutions that make hydrogels, that's totally compatible with our gel formulation and process. So we're just gonna use the same SOPs and the same standard procedures and manufacture the machines. Yeah.
Then if they can do that, then why is your company needed?
Well, that's about making it, right? It's the formulation and the conceptual breakthrough here. It's what it stands out from the competition.
Can you give a sense of what that might cost to be able to create at a per kilogram level and how that stacks up against what folks are paying now for like the main market retardants?
Yeah, that's a really good question. So instead of not just being eco-friendly, but also effective, it's also cost efficient, which it's proven by the estimations we've done in terms of, for example, our gel per kilogram would cost around 3 to 3.5 US dollars instead of the normal, which is 8 for the competition. And in terms of returns, it's so.
And the 3.5 is what you would sell it for, or that's what your production cost would be?
Like around a 60% gross margin, which would put the price on like 6 to 5 US dollars per kilogram. Yeah, and that's still even more cost effective and cheaper to make and cost effective for us to sell because of its more cost effectiveness in the making, but as well on the volumes that are needed per acre, for example. So when the competition would require, let's say, 1,000 liters of gel per acre, we have around 80% reduction of the volume. So we don't need that much of the gel per acre, and we're able to therefore be more cost effective and address a different type of market. And that's actually why we can stand up against the competition, because this monopoly, basically it's a commodity model because they sell cheap but toxic phosphates and ammonium retardants. And so because of its legacy volumes, they sell it at massive scale. They're not going to be able to enter into the high effectiveness model that we are.
Could you elaborate a little bit how you are effectively really putting this gel on the ground? Is it in a preventive maintenance or preventive way or reactive way? So when you have a fire really happening, and in that case, how you pour that on the floor? Or if it's on a preventive way, how long does it really stay on the ground, and how frequently you need to probably replace it?
That's a very good question and a good clarification. So both performances, it can be effective for the gel. So in the preventive side, we're going to focus on high-risk remote areas that we know where it's happening and when. So for example, when the dry season comes, the gel is going to be applied like a month before, and it's still in review, like the different, like the wind shear and all the different factors that are going to influence that. But we are positive that we're going to be able to maintain the gel there, and then external factors like the weather are not going to affect. And then in terms of suppression, it's going to be focused on applying the gel from an aircraft, for example, and the normal firefighting tools that firefighters use, like water hoses, like the pressurized ones. And the cool thing about the gel is that it's a fluid when it's on the hose, but on the pressurized hose. And when it hits the tree trunks, it becomes a shield, an insulating barrier for the temperature to basically avoid the ignition point. Thank you.
Thank you so much. Up next, ignition packaging.
Testing.
Protective packaging has become a staple in society, with shipping being one of the most prominent ways we deliver goods. But after they've served their purpose, this is where they end up. Piles of styrofoam sitting in facilities like this, where they aren't recycled, they're merely relocated. And they're relocated to places like these: our beaches, oceans, and the ecosystems that sustain life. Expanded polystyrene, known as styrofoam, then goes on to persist for over 500 years and effectively outlives us. The problem is simple. Styrofoam packaging is destroying our environment because they never truly break down. Styrofoam is killing our planet, but we're here to save it. My name's Abdu. I'm the founder and CEO of Ignition Packaging, where we are introducing the solution, Ignition Biofoam, a sustainable alternative that protects marine ecosystems, prevents pollution, and eliminates health risks from toxic packaging. And our competitive advantage is in the fact that we optimize on agricultural waste locally sourced from farms as our cellulose feedstock to create a cost-effective, structurally stable, but biodegradable solution. The global foam packaging industry incorporates markets like home and appliance packaging, food and consumer packaging, as well as biotech and medtech packaging, not to mention the Amazon packages I'm sure you all have seen with tons of styrofoam. Altogether, this encompasses roughly around $20 billion in market value, and growing annually at 7.6% is the biodegradable foam market. It's currently valued at $1.2 billion, and this is where we're poised to have an impact by introducing a product with over 250 days of shelf life stability, superior strength when compared to conventional styrofoam, and 100% total decomposition over a 60-day period of being in landfill environments. This is a snapshot of our customer product, the Ignition Biofoam, in the form of packing peanuts, and to the right, a new recent innovation, the Ignition Biofoam, in the form of vial encasements. This is essentially our go-to-market products for preliminary customers in the biotech sectors. But we begin with agriculture. We source agricultural waste from farms, which we then transport to our labs. There we extract the cellulose and bind it together with plant-based plasticizers to create and sell our biofoam to the customer. But this is where we revolutionize the industry. Farmers pay us to collect the ag waste. We then create the sustainable packaging and we sell to biocentric companies. Effectively, what we've done is we've built a dual revenue model that generates a return not only on the front end, but the back end as well. It effectively costs us $0 per ton to acquire our feedstock, $500 to process that, generating the output revenue of $766 and the grand total gross profit of $266 per ton of feedstock. This is at 34% margins, showing that profitability and sustainability can grow hand in hand. On the note of carbon footprint, conventional styrofoam uses a feedstock of styrene and emits 3 to 3.5 kilograms of carbon emissions per kilogram of styrene. But when you use cellulosic biomass like we're doing at Ignition Packaging, we're showing a reduction to 0.7 to 1 kilogram of carbon emissions. This is effectively a 70% reduction in carbon emissions from conventional styrofoam, and it's the impact we're after. On that note of comparisons to conventional styrofoam, Styropec is the leading styrofoam manufacturer here in the United States. They operate under a petrochemical blend, are not biodegradable, and have no implication to our environment. When you look at the landscape with biomaterials competitors, Oasis operate under a semi-petrochemical blend. Though they're biodegradable, they take progressively longer than us, but most importantly, they are simply not cost effective. Another innovative solution in the biomaterial space is Ecovative. They use 100% mycelium, which is natural, which is sustainably sourced, but the problem about mycelium is the high variability, and in some cases, it takes weeks to manufacture, whereas us, it takes just 48 hours. Due to the fact that mycelium takes a long time to manufacture, it is not cost-effective or scalable, and that brings us to Ignition Packaging, where we operate under a 48-hour period of agricultural biomass to end product, and we do so while maintaining structural stability, outperforming in biodegradability, and most importantly, being cost-effective. And that's important when you look at the integration into modern-day supply chain. But we begin with agriculture. We begin with our R&D collaborations with agricultural cooperatives, one of them being Florida Crystals, one of the largest sugarcane cooperatives in America. Here, we're sourcing our cellulosic biomass. We extract the cellulose and create our end products for our 3 customers who signed LOIs in the biotech space. Here, we're packing peanuts and vial encasements, but what the road looks like from there is breaking into marine and coastal applications where we'll be making things like clamshells, cutlery, and other styrofoam replacements for locally affected communities. But the grand total goal and mission is to break into single-use packaging where we'd be able to have an impact as follows. 380,000 tons of styrofoam enter the ocean each year. And with just 10% market reach, 38,000 tons would have never made it to our waterways. This is the level of impact we're after at Ignition Packaging, and it's fueled by the roadmap that has led us to this point, where in just over the last calendar year, we've hit 3 major R&D milestones, secured 2 R&D collaborations, and obtained 3 LOIs, showing not just technical, but market validation as well. So just to recap, we have 3 signed letter of intents. We fundraised over $60,000, all in non-dilutive funding that has gone right back into the research and development that has helped with innovations like our over 250 days of shelf life stability for logistics and transport. We've done this while being supported by organizations like news outlets, to university institutions, and even accelerator programs that have given us the vote of confidence that we are on the right path. And by we, I mean Team Ignition, where I serve as the founder and CEO. My journey in sustainability dates back to when I was just 10 years old, making biodegradable science projects. After that, I've been in the United States Department of Energy as an energy consultant, giving audits to factories in the southeast region of the states on cost savings and sustainability implications. I've also been a director of sustainability for Nucleate on biotech funding, helping scale 10 other startups in the sustainability and biotech sectors to funding and getting their resources going. I'm joined by the Chief Science Officer, Evan Phillips, who's pursuing his PhD in polymer science at the University of UC Santa Barbara, and he's done top research at American institutions in the sector of biotech and materials engineering from the University of Delaware, University of Minnesota, and more. We're joined by lead product engineer Thomas Brown and our R&D engineers Julia and Christian, who are holding down the fort in Florida and have also done renowned research in the biomaterials space. And we also have 4 new interns on the analysis and business side, helping us scale when it comes to outreach on agriculture, biotech, and internal operations. And altogether, we have an encompassing team from business to technical validation that get the job done. We're empowered by advisors that give us the academic, business, and executional principles needed for a sustainability venture. And that leads us to this point where so far we've achieved our cellulose extraction method, chemical compound formulation, and in-house biodegradability tests. What the road looks like for us is the process optimization and industrialization, as well as the customer launch and system validation. But what this exactly entails is a competition like the MIT CEP, and the potential funding from such would go directly into this capital allocation of product batch runs, machinery scale-up, as well as supply chain validation for feedstock consistency with our already in-present agricultural partners. The next step in Q3 of 2026 would be on customer launch and system validation, shipping with our already LOI signed customers, the transit status benchmarking, as well as packaging line integration trials. And this gets us to a point where we're achieving recurring revenue with our 3 LOI customers. At Ignition Packaging, we're challenging the status quo of what packaging is and can be. The goal is not to merely compete with other biomaterials competitors, rather pave the way for a new level of competition with a new generation of packaging with the conventional styrofoam. At Ignition Packaging, with your vote of confidence, we can make that happen and make it one step closer to a better world for tomorrow. So with that being said, let's ignite that change. Thank you.
Thanks. In terms of the unit economics you showed, where the farmers are contemplated to pay you to take off the waste, how confident are you in that? Have you ground truthed that? Because I think that might be challenging.
Yeah, I'll tell you, the very first part of starting Ignition Packaging was understanding the agricultural scene. I don't come from an agricultural background, but the first step was doing outreach to every PhD and every agricultural professional I knew in the area. And when doing so, I understood there was a major gap in the industry, and that is what is being done with the agricultural waste. After having these conversations with now farmers, what I've understood is that with their biomass waste, they'll either burn it, and that is bad for the environment, takes time, money, and resources, or they'll give it to waste management and have to pay waste management. And so what we're doing to the farmers is we're saying, hey, let's come in at a fraction of the cost you pay waste management, and then we'll take that material off of you and use it for the rest of our process. But you ask a great question, because the question we've been getting recently is on what makes us different from another biomass competitor that uses and upcycles our waste stream. Whereas other biomass competitors just take and take and take, what we've done is after we've realized when we extract the cellulose, we're left with highly nutrient-dense organic matter. And so the partnership there with farmers is we're not only taking off the waste that you don't need anymore, but we're giving you back, we're providing back a nutrient remediation for the soil. So you get the added benefit of not just disposing your agricultural waste that you have nothing to do with, but also propping up the economy in the agricultural scene. And that is a high competitive advantage when you look at the agricultural space.
Maybe staying on feedstock, take that a couple steps forward as you think about scaling. What does your logistics look like as you continue to aggregate that feedstock, and maybe paint that picture for us?
Yeah, so I'll speak to confidence with exactly what we're working on in the next 6 to 12 months, and that is building the profit-generating blueprint that goes from farm to end product with just our first customer, because that blueprint gives me just enough information to understand where do I go for where to scale. So I was just talking to a gentleman earlier about this today. The way we look at sourcing agricultural waste and the logistics of such is two main factors: cellulose density and how widely available is it, based on the relative location of extraction point being the lab and the manufacturing. So for example, sawgrass has a cellulose density of 35%, but it's very widely available, whereas sugarcane has a cellulose density ranging from 45 to 55%, but it's native in areas like South Florida. So granted, having a facility like ours based in Florida, it makes sense to use something like sugarcane. But if you're in the Midwest, you'll see corn, which has a cellulose density of around 40 to 45%. And so the beauty, to reel this back in, the beauty of what we're doing is cellulose extraction it works with any crop that we target. The real challenge is conversion of that cellulose into biomass and how much waste product we have, because that is an indicator for how much sales we can do with our biofoam.
Got it. And for your first customer, can you give us a sense of just the volumes of what you're able to source?
So the first customer, it's a really good partnership. They're a small to medium-sized biotech customer. And so we don't have a high rate of production like you would with a higher level customer. But this is a perfect point for us to prove out profit generation before we onboard our second LOI to a paid pilot and go from there.
In terms of the amount, the amount of farm you need to fill a box of packing peanuts, give us a sense, how many liters of packing peanuts per acre?
Per acre. I've never heard that kind of.
Anything
Yeah,
like
no.
that.
I'll paint a picture. And so if you have a solid bag that's, let's say, a kilogram of biomass, you can approximate around, for us right now, 50% on average of that becomes a biofoam.
Right, and then the biofoam is foam, so how much space does that then take up?
It's all depending on the end product application. And so if it's packing peanuts, then we engineer it so that it can take a little bit more space. If it's a vial encasement, it's inherently closed off. And so it's really, to speak a little bit more to our value proposition at this stage, it helps us out being a small startup because we're allowed to go to our customers and custom design it to their needs as we continue to scale. I think eventually we'll reach a point where we have a uniform packaging that integrates into modern day supply chain based on multiple needs. But that's really what the goal is right now.
Got it. And while I've got you, can you talk about how you're different from starch-based products?
Yeah, so we're different from starch-based products. A lot of what goes into what makes us different on that end is our blend and the fact that we're able to keep it on low costs. So that goes to the proprietary nature of our ratios. That goes to not just the chemistry. And this is a major point that I want to hit on. A lot of times when you look at sustainable packaging efforts and why they fail, it's never really just about the chemistry, but it's about the executional principles that range from feedstock to end product. And so what we're doing is a little bit different when you're looking at upcycling that ag waste. It's not just upcycling ag waste, but it's propping up an entire agricultural economy.
Could you elaborate a little bit on the IP, even though if it's still a kind of execution play, what have you protected and how you would really prevent other incumbents from replicating?
Right now, we're under trade secrets due to the recent nature of our innovation, but we're currently working with advisory council and the legal side of filing our utility patent. And from there, we want to expand the claims and cover different forms of packaging. But what I want to note is sometime after a year of that filing date, the goal then would be to do a PCT so that there's international protection and we can scale globally. Because once again, ignition packaging, what I really want to harp on is the fact that this doesn't need to just be a small local effort or even just an American effort. France alone emits around $15 million or 15 million tons of agricultural waste with just crop alone per year. That's just France. China alone has 300 million tons of corn that's produced a year. So around the world, there is an abundance of cellulose-dense material. Cellulose is the most abundant polymer on Earth. The problem to solve is how do we convert that into a value-added material that can replace what's hurting the environment at a financial rate.
Could you just also elaborate on what the manufacturing process would look like? Do you want to own your own factories and how complex these factories would be, how capex intensive they would be?
Yeah, so with intellectual property, we have the option to actually license our IP. And so one of the things that we're also doing is we're not just making any formulations, but we're engineering them so that they seamlessly integrate into existing manufacturing lines, into existing facilities. And we're working on this by testing it in facilities that currently make styrofoam with our biofoam formulation. So what that does is it reduces the integration cost because you're not requiring extensive retooling, and in turn, you're operating almost as a plug-and-play venture with our material. And so that's another added benefit to our proposition.
I think maybe the final question, I think like building off what everyone said, obviously, if you get to the volumes you're aspiring to, you know, packaging everywhere, price is going to be absolutely essential. And you kind of had that a few times. Can you break down that $500 number for me? I think I might have seen it as you flick through, but like what's actually going towards that in terms of transportation, everything else? What is?
Yeah. And so the $500 cost really is on the reason why the feedstock cost is so low is we're coming into the farms and getting a profit that covers at the very least logistics and transportation. So we're starting at a net zero. So that's a conservative case in the event that we don't get paid more than just logistics. What that means for us is when you compare it to styrofoam, the feedstock cost of styrene is $1,100 per ton. Now, styrofoam as an industry makes a lot of money due to the high capacity of volume that they put out. But at the end of the day, they operate under low margins. Our margins are higher due to the early stage of our startup. But really what that $500 is the process and manufacturing of extraction and creating the actual biofoam. But this is a side-by-side comparison with our process and manufacturing, our numbers compared to styrofoam. And the great thing about this is, we're such an early stage startup. The sky's the limit if we're already showing this return. And I must affirm the reason why we're showing this return is we're not just thinking about the science, we're not just thinking about the extraction, but the whole big picture of connecting logistics. Thank you.
Wonderful, thank you. So last but not least, Shinra Energy, last pitch of the day. Welcome to come up.
Is this on? Okay. Okay, we'll get started. So we're Shinra Energy, and today we're excited to share with you about our technology, which is geothermal exploration technology developed by Tohoku University in Japan. As you may know, there's a significant momentum behind geothermal sector right now. Currently, there's about 14 gigawatts of installed capacity globally for geothermal, and this is expected to grow by 6-fold by 2050. And the reason behind is it's a clean baseload power, and also there's a lot of innovation that is feeding into driving down the cost of geothermal. And this is just the conventional number. And if you include the next generation enhanced geothermal technology, this number could be much bigger. However, it has its issues as well. So geothermal is pointed out as inherently risky. And the reason why is you don't actually know what happens at subsurface level until you drill, much like oil and gas sector for gas development. And so DOE suggests there's about 33% that you hit a dry well, which is an unproductive geothermal well. And combined with that, it's got a high exploration in CapEx. So about 80% is upfront CapEx. And it takes about 5 to 10 years for construction. So before you see a dime in your revenue, it takes about 5 to 10 years to actually develop a geothermal plant. And with Shinra Energy, we're trying to tackle this issue by commercializing a new technology. We are trying to analyze the subsurface stress levels for successful drilling. So stress actually controls the subsurface architecture of a geothermal well. Sorry. And as you can see, what we're trying to do is by taking a core or a rock sample about 2 feet in length from your geothermal field, and then we analyze the stress level that was, the in-situ stress level that was applied to this core. And this will help us do a 3D modeling of a geothermal reservoir, as you can see on the bottom picture. And we believe that stress-informed drilling can reduce the drilling cost by up to 10 to 20% and reduce the construction times, because we'll be reducing the number of wells that we develop and also hitting the dry wells. If you take a step back, this process of coring or taking a rock sample, it's nothing new. This is a conventional practice in oil and gas. As you can see, that's the typical conventional coring technology. But the issues with the current technology is it's not optimized for geothermal. It doesn't endure the high temperature and high depth that is required for geothermal operation. But also, it's not optimized to measure the stress level, which we think is necessary to get a better understanding of the subsurface geothermal wells. So the technology, and I'm going to take a minute to talk through this technology. This is a simplified diagram of what we're actually doing. When we get to the depth that is required to measure the stress, we instill our coring technology. And if you look at diagram B, and this is called a dual bit coring. So it's got 2 drills. With the outer drill, we drill the outer groove. And if you look at section A, it releases the stress horizontally outwards. And then with the second drill, which is the inner drill, we drill through section A and also deeper to the Earth's ground. As you can see, then we'll get section B and section C. Section B, because the pressures are really released from the initial drilling, will stay the same in the diameter of the bit that we used. Section C would expand because it's been released for the first time as we drill with the inner drill. If you measure the difference in the diameter of these sections, you'll be then able to detect the expansion, and therefore you can detect the stress level. This is a simplified version of what we're doing, but this is in a nutshell how we're thinking of measuring in-situ stress. And so just to add, we're also going to add an electronic compass, which would endure the high temperature and high pressure, which is absolutely necessary because we're not only measuring the size of the stress, but the orientation, so that then you can develop the 3D modeling of where the fractures are. So this technology has been developed over the last 8 years in Japan under government funding from Japanese government funding. And the concept has been proven. And we've done a field test at a depth of about 100 meters at a diameter of 10 centimeters in terms of the coring technology. The next step is to go deeper, which is going to be a pilot level or a pre-commercial level. And so we would say this technology about technology TRL of 7 to 8.
So the next question is, how do we commercialize, or how do we think about the business model for this technology? Before we understand the business model, we would like to understand how a typical geothermal project is developed. We have 4 key main stakeholders, which are represented by the project developers. You also have the surveyors, or the exploration and surveyors, who provide the data analysis. You also have the service contractors, who are responsible for the actual physical drilling. And finally, you have the EPC contractors who build the physical plant once the project is identified and finalized. What makes difference between the project developers and the other stakeholders in this project is the amount of risks they take. In a geothermal project, since exploration is very high, most of the risk is taken by the product developers, as opposed to all of the other players who are only acting on a cost plus fee basis. And therefore, when we think about how do we sell the technology, our largest client would be the product developers who are actually taking all of the project development risks. What Shinra offers is 3 main values. The first one is on-site stress measurement. The second, interpretation and simulation. And finally, actionable advice. We provide an integrated solution where we carry out the actual coring, as well as the analysis based on the coring samples that we collect. How do we sell this to our potential customers? Well, since most of the risk is taken by the geothermal developers, we are planning to provide the service in return for a service fee. The economics are also important. In a typical 50 megawatt geothermal project, we anticipate the cost to be 196 million. With a tariff of 8 cents, the project IRR is estimated to be around 7.2%, and the equity IRR about 13.1%. However, by implementing Shinra's technology, we would be reducing the cost. I just want to highlight that our technology is in addition to some of the existing activities that are carried out on site. And therefore, when you compare the test drilling and reservoir evaluation costs between the 2 comparisons, there is a $2 million increase in the cost. However, since we do the stress management and reduce the number of drillings that need to be carried out throughout the project, we will be able to reduce significantly the production drilling cost from 70 million to 49 million. This would give us a project IRR about 8.4% and an equity IRR about 25.5%, which is a significant benefit for the project developers. Also, I would like to highlight that since the technology would enable us to drill more efficiently and more precisely, it would also reduce the construction timeline from currently 6 years to 5 years. Before we move on to our final slide, we would like to introduce ourselves.
So my name is Kosuke Kobayashi. I'm a second-year MBA student at Harvard Business School. Prior to business school, I spent 6 years at Mitsubishi Corporation in energy and metals trading. And subsequently, I spent 6 years at a venture capital fund called AP Ventures, which invests into hydrogen and early-stage climate technology. So what I bring to the table is early-stage growth for a startup in the climate tech space.
Hello, my name is Shota Araki. I'm also a second-year MBA student at Harvard Business School. Prior to HBS, I was working for a Japanese trading investment called Mitsui. My expertise has been developing an infrastructure across the world from oil and gas, solar, to water treatment projects. We also like to introduce Professor Ito, who is our scientific collaborator from Tohoku University of Japan, an expert on geothermal development and subsurface analysis. Finally, going forward, over the next 12 to 18 months, we anticipate several milestones, of which one of the most important is to convert current customer conversations into an actual pilot deployment project. We also plan to engage with additional geothermal developers in the field, as there is a rising number of players in this area. In order to finance our project, we plan to raise 1.5 million to $3 million US, considering the fact that this is a very capital-intensive project. And we hope that the CEP Finance Prize will allow us to accelerate some of the developments that we're carrying out. Thank you so much.
Thanks for the presentation. Very, very interesting. Few questions. Let's start, but in your team, who really deeply understand the tech that has been developed and being sure that if you need to make any type of adjustments in the technology itself, the IP will still be owned by the company?
Yeah, so currently the technology is developed by Professor Ito, and he's the person we go to for technological advice. There is an industrial partner in Japan who helped develop this technology, which is more on the manufacturing side. So they will be our natural partners to help us navigate through some of the technological side. Maybe to touch on the question about IP licensing. So right now we're not fully licensed from Tohoku University, but we're in conversation with them. In Japan, licensing technology from university isn't as frequent or often as you'd see in the United States. So we're navigating through that conversation by gathering data from other universities and how it happens and transferring some of the knowledge from the United States to the Japanese university to navigate that conversation.
One additional one, you were mentioning that you have an additional cost at the project development level, but then optimizing the TCO, total cost, let's say, of the project. However, if you are the project developer itself, does it mean that you would be able anyway to sell at a higher price the project rights to the EPC? Or because, and maybe I'm not educated enough on how you go through geothermal, but usually in all these other project development activities, things about solar farms, things about utility-based activities, you have the project developer which are really reselling the project rights to an EPC or to a financer. So, or let's say the off-taker. So here, is it, if it's the same, does it mean that the project developer would be able anyway to sell these project rights at a higher price or not?
Yeah, I think one of the I don't know if I answered your correct question correctly, but the idea here is that since the developers are the ones who are taking the highest risk and the development costs are pretty high in this sense, by them allowing to use our technology, they would reduce the capex of the project. And if this is selling to, if you think about how the PPA is organized in these type of project, a smaller capex, I think, would subsequently allow you to have a better tariff offer. And if this is a private deal, instead of like selling it to the market, you would be able to, I guess, have like a better offer in the PPA.
Yeah, my question was just slightly different because once again, the value chain is maybe slightly different there, but usually project developers are really selling RTB, ready to build project, without yet even initiating the single drilling or whatever construction work. And that's another stakeholder, let's say the EPC and the off-taker, which are paying all these activities. So the one that would bear the cost is the project developers, I assume.
So maybe to answer your question, I think traditionally developers would continue to own and operate those sites. So companies like Ormat or some of the newer ones like CERC and others, they would traditionally develop and manage those sites because there is expertise in managing it is probably more cumbersome to manage a geothermal well than a solar plant because you need to continue to measure the productivity of those wells. And if needed, you need to drill a new one to connect, to make sense of the existing sort of turbines that you built.
So what do those relationships look like for you at the moment? I mean, there's an increasing number of geothermal players, but it's not, an infinitely long list. So yeah, how does that look like for you right now and going forward?
Relationship with the developers.
Yes, with your target customers.
Yeah, so we have a number of ongoing conversations. And I think there's general interest in deploying new technology to de-risk dry wells. But as you say, there is limited number of technologies, so companies. But all of them roll right now. There is a lot of policy support for geothermal as well. There's interest from large tech companies. So I would say the development cycle of these geothermal wells are on an uptrend. So those relationship, I think, is welcomed right now. And I think there's a potential that we could try to get them to use our technology in the near future. But I don't know if that answered your question.
It does, but I guess the question is then, okay, great, you have some conversations with them, you show them something, but how can you actually, how are you going to get them to bite, right? You can
Yeah.
kind of show them some numbers. How are you going to like take that next step with your early customers?
Yeah. So the premise behind numbers that we're going to raise is we believe that the first few trials are going to have to be paid trial by ourselves. So it's going to be it is a traditional market, geothermal market. Developers are risk averse. So we need to make sure that we have the credibility first, ourselves and the professor, but also we might need to foot some of the bill to try the technology and share with them the data. And so they're going to go through with us the journey. And then once it's more accepted in the market and the data is proven, that's when we try to have a fully paid customers.
Let's talk about market size for a moment. At $2 million of revenue to you on a 50 megawatt project, the overall slice of the geothermal industry you can take is relatively small. How do you see making this a venture backable company?
It's a great question. So I think our TAM is insignificant. For like all the geothermal well development and this pre-study phase, I would say the TAM is between 500 million to $1 billion. We think there's two opportunities for an exit for this company. One is we would get to that pilot scale or where it's commercially acceptable and we have a backlog of potential customers. And this technology might be better housed in a larger organization like Schlumberger or Baker Hughes or others who actually do the services. And so there might be our role might be just bridging the initial stage. However, we do think there's an upside in which if this technology is truly differentiated, we can develop some of those wells. And then to your point, there might be a market for secondary of developed wells that we can serve into. So there are AI-driven geothermal exploration companies that are trying this route. We might follow the footsteps if you think there's a void in the market where we can fill. But I think we just need to be conscious of the amount of capex that we spend in building this technology and in finding the right time to exit. We can't be a $100 million company selling to Schlumberger after 3 pilots. We need to make sure we manage the valuation, the maturity of the technology that is right for the end owner of this technology.
A couple quick clarifying questions. So on this slide, going from 70 million to 49 million on the production drilling, the primary mechanism for that is avoiding the wrong production well?
Yeah, so I think wrong is difficult because some of the dry well doesn't produce any heat.
Right.
It could produce some, but it's not as productive.
Right.
And so our assumption is we can reduce the number of wells by hitting the big reservoirs that actually are most productive.
Got it.
And so going from 20 wells to maybe 15 or 14 would lead to this kind of number.
Okay, and then second clarification, the core IP is in the bit that does the dual cut, or it's in the modeling effort that happens after to basically
It's the concept
extrapolate.
of using dual bit for this purpose for measuring in-situ stress for geothermal operation.
Okay, thanks.
Thank you so much. Great. So now I will ask our judges. Michelle will lead you to the room. We're going to have a panel while you all go off and deliberate. And in the meantime, for you all, we have an excellent panel coming up for founders that were in your shoes not too long ago. So I'll invite my panelists to come up and join me as well, and I'll give a short introduction and launch right into it. Great. Okay. Let me see. We need 3. That's all. I guess we have one. We'll take a short, like a few minute break if anyone wants to grab like some coffee or snack. We'll get set up. But be right back in. One more.
Do you need me to kick it off or are you gonna moderate?
I'm gonna moderate.
All right, good.
Yeah, it's just again. Nice to see the jacket still strong.
Boris, it's
Wait, is it new?
the new jacket.
Yeah,
New jacket.
I
jacket.
know.
Still jacket. They've upgraded since. Yeah.
Yeah, I know, but I saw something different. There's something different.
Oh yes, there will be a video where we drop this jacket into the reactor, then it dissolves away and go into
The showmanship.
Yeah, that's the story.
I'm trying to find. I've seen him. He's here.
I've seen the bathrooms. Can you check the bathroom?
That's not.
Can you check the bathroom?
Dude, I'm not. They go young.
Your armed forces, buddy.
He was Army and he was a pilot. Like, we were speaking different.
I'm May. Yeah, thank you so much for doing this. We appreciate it. Sorry, we're just looking.
Like lots of pictures for a hat, I guess.
How many panels have you been on with Helix Carbon?
I guess every other. I don't know. We're like putting the world together.
Yeah.
Probably tell their story too.
I mean, it's awesome. Yeah, yeah.
Well, that's good.
All right. Decarbonization of chemistry. Talk. Yeah, we sometimes pitch each other. So.
Sounds like.
I mean, David was the Delta V mentor in the cohort that we were Delta V, and then only to become the Delta V, participant the year after.
I'm a supreme disappointment because I was also a Delta V grant manager, also military. So they were like, "Oh, you're gonna go do a startup now, right?" And I was like, "I wanna." And David got so cool.
It's cool.
I'm gonna throw out that David got a little lucky. He made a lot of his own. I'm not. I was in the Marine Corps. So David was at the Army. I was in the Marine Corps.
Yeah, right.
Yeah.
But he was flying
It
the
is.
Army.
Mhm.
You know that is usually because come on.
The helicopters specifically for the Army are big, are like a very normal thing. They don't have jets. That's the big difference. I call.
We can just lunch this.
This is the thing. He's here.
Probably. Oh God, no, I don't know. Shouldn't.
Why would any other?
That's true. As well. Yeah. Like that helps a lot. Like that helps.
Now he's just ignoring me.
Did you take his WhatsApp or his regular? We try his WhatsApp.
Is his WhatsApp number different than his regular number?
Probably not, but maybe.
You know, maybe he'll answer you. That let's
Okay,
try
we'll
that.
do the test right now.
Yeah. It's 8509.
Yeah, you just say, okay, yeah.
Run right in. And it will ultimately be
Ghosting me as
fine.
well, so no difference, yeah. Okay. We'll do the panel by ourselves then. Well, he'll drop it at some point.
Yeah.
Oh. Founder, right? Yeah, sure.
Okay, guys, we're gonna start the panel now.
Yeah.
Okay, thanks everyone. We're gonna go ahead and get started with our panel. And David's gonna pop in soon. Oh, there he is. Look at that. Good timing. Okay, great. So we're gonna go ahead and get started. We want to thank, first of all three of you for being here today to talk about what you're working on and kind of share some of the stories of when you were in the shoes of some of our founders who are here today. So to start out, to introduce, we have Gareth Ross, who's the CEO and co-founder of Sora Fuels. We have Jan George Rosenboom, who is the CTO and co-founder of Macrocycle, and David Brown, who is the co-founder of Helix Carbon. So I can launch into it. We're going to start out. I'm going to ask some questions, but please think of your own, because the last 15 minutes, I'm going to be sure to leave some time for you all to ask these founders your own questions. So to start, could we just maybe go down the line and just give a brief introduction to yourself and to your startup?
Yeah, sure. So Gareth Ross, somewhat non-traditional path to this particular role. Spent about 20 years in corporate America, worked my way into #2 role on a Fortune 100 company, hated it, quit like a decade too late, and joined Engine Ventures as an EIR, where I met my co-founder, who you will hear is responsible for the origin of the sort of the tech and the idea behind Sora Fuel. Joined him, and we founded literally almost 2 years ago to the day.
Amazing. Yeah, my name is Jan, co-founder and chief nerd at Macrocycle. My background is mostly academic, cooked around in labs in Europe and at MIT for quite some time, 10 years, and then always had the entrepreneurial spirit to like, I want to get this into the real world. And that magic happened when I met my co-founder, Stuart, in a class called Climate Energy Ventures. And we went through this beautiful CEP prize as well. And that's 3 years ago, exactly to this day. We were right here on this stage, having a different name back then. And since then, pivoted the name, pivoted the technology, pivoted the market, and still running.
I think you still got the check upstairs too. I see it every day.
It's true. We'll never forget.
Yeah. I'm David Brown. I apologize for being late. I don't have an excuse, so I'm sorry. I am a co-founder and COO of Helix Carbon. Prior to starting this, I was in the Army. I was an Apache helicopter pilot and operations officer. And then I got into Sloan, where I met my two co-founders, Dr. Ariel First and Evan Haas. And we are working on CO2 utilization for iron and steel.
Great, thank you. And can you all, kind of go down the line again, talk a little bit about just your company and the key differentiator, either between, the technology you're working on and the incumbent solution, or just the key differentiator that makes your technology special?
Yeah, sure. So we are in a much maligned space these days, although we think it's coming back up. So we're in making sustainable aviation fuel. What sets us apart is we can basically take direct air capture CO2, so atmospheric CO2, at like 90% less than anyone else can do. So we can bring down the feedstock costs for making fuel, and that's the differentiator that I think, there's lots of other reasons, but that's the thing that is really unique about what we do that is hard for others to replicate.
Yeah, so we with Macrocycle, we're solving the $1 trillion fashion waste crisis. Basically, everything we wear gets tossed out and incinerated eventually. There's no recycling, literally, besides a little bit of rewear. And so we're in the space with 50 other startup companies that are trying to do PET, polyester, cotton, elastane recycling. It's a blended material, which makes it very hard to regular recycle it. And so everybody goes at it mostly through breakdown processes. Take the material, break it all down to monomers or fuels. They have to be refined and then put back into the supply chain of petrochemicals to make new polymers and polyester fabric. And that's expensive. And so our technology is the only one not breaking things down. In fact, we're not breaking bonds, we're making bonds. So we can recycle the PET and the polyester in this jacket in a much cheaper and more effective way.
Similar to Sora Fuel, similar to Gareth over there, we are doing CO2 utilization. However, we are not using our CO2 off the back of a capture unit. We're able to react with carbon dioxide directly out of dilute and dirty waste streams, which is something that really no one else can do. And so what we're able to do is put our system on site at an iron furnace, take in the waste streams in their entirety, convert it right back into the exact same gas that they're using fossil fuels to make today, re-inject it into the furnace to offset fossil fuels, which not only saves emissions, but will also save them money at scale.
Thank you. And I'm curious, because a lot of the founders here today are students and are considering, do we do this full time after we graduate? I'm curious, what were the signals or milestones that gave you the confidence to pursue this opportunity full time as you were considering it? Sure. And we can shake it up if you want. We can start with David.
I'm good.
I mean, I would say, just to shake it up, I'll go first. We can point again 2 years ago today. We were on the stage and we were at the Climate and Energy Prize, and that was a huge signal for us that we were on to something. Now we have since pivoted a ton from what we were originally doing. Sam's nodding his head; he remembers. It was still in the basic area of CO2 utilization, but we've pursued something different. But the point was, having that an early validation of, I don't know if any of the competing teams are in the room right now, but just being in this room is a good sign that you're at least on to something, and being able to pitch it to these judges and get their feedback, even if you don't win, is like, that's real feedback that's helpful, and you can use that to go forward. And even if what you're originally pitching isn't working, you can find something that does. Jan?
For me, it was twofold. It was the founder fit and it was money. I didn't want to do this alone, and I couldn't do it without money. And so in the class, I met Stuart, my fantastic co-founder, and we went through the class, like working a little bit on a business case, and it was kind of just an idea, maybe like you guys have an idea currently. And so we were like, after that class, pressure testing if this actually has potential. Both, can we work together through hard times and do some day and night gigs to meet some deadlines, and can we actually attract some money? And so Stuart and myself, we said, okay, yeah, we want to do this, but we don't have any money. So yeah, we can go to these pitch competitions, which are great, but they're not enough. In fact, we need to look forward. We need to talk to investors, have these tough questions asked, like the panel is asking great questions, actually. And so we were able to win $500,000 from Breakthrough Energy through a competition that we supplied, and we went through several nights, and that experience, grinding it out, but really having fun doing it, and eventually winning that money, that was the kicker for us to, yeah, looks like we are onto something.
I wish I had that story. We didn't really have a signal. So we're making a product that we know there's no product market fit, right? So we're making a commodity product, and we know if we can make that product, we're good. What we had the luxury of is we were both working essentially at a venture capital firm, and had, Patrick, my co-founder, has sufficient sort of technical knowledge. I kind of the business side. And we spent about 6 months building internal modeling and saying, like, if this actually works, is there something here? And then we jumped out on that basis without what I would say is a true market signal. So a little bit more fraught, but it has worked out.
Helpful, thank you. And somewhat moving, chronologically, but as you've decided to do this, perhaps it was even before you decided to do this, but curious, what were the primary questions or risks or roadblocks that you faced as you were moving this technology from the lab stage to actually founding a company? Start with macrocycle.
So many. I mean, yeah, you need to hire a team. So how do we even define what are the roles that we need? And so being guided by, okay, what are the technical challenges we have? And we've been being, I mean, at least we were trained, it was drilled into our heads through Delta V, thanks to this guy who was the lead mentor there, that we need to be customer driven. Like whatever technology you're developing, and maybe the PhD folks here in the room, like myself, we needed to learn not to be too married to the technology, but really to be married to the problem. And so we think we have a good technology, but it doesn't matter if the customer doesn't need it. So really going out there and probing what the customer wants informed what technology we need to develop, that informed which kind of people we need to hire. So that was the first realization. It wasn't so easy in the beginning, and maybe I'll stop there.
No, that's totally, that's the answer, right? And that's something that we struggled with early, because we're a tech to market push. We really can only do one thing. Like we turn carbon dioxide into carbon monoxide, and that's a tough sell, right? It's like, what if we turned your waste, right, into a gas that's poisonous, flammable, and you can't smell it? People don't want that, and so they really don't. And so it was like, okay, we have to find someone who does, or someone who's already using it, and find some signal that they're actually willing to purchase what we're selling. So just being customer driven is the key there.
We also make carbon monoxide, a poisonous flammable. We mix that with hydrogen to make it really explosive.
That's the secret. That's the secret.
That's the secret.
Even more explosions.
Even better.
I think, look, I think for us, the challenge which I think persists to this day is that, I think as we sort of emerge into the world, the green premium on fuels in the US was sort of getting eroded as, quite frankly, as Trump was coming to market. Probably the wrong term, but maybe the right term. So the question we have, which is, if you can take waste CO2 and hydrogen and convert that to fuels, can you do it at a price point that airlines will pay for? And it's basically the core question. So it's a very much techno-economic question. And I think we have to convince ourselves that we could hit those economics in ways that felt believable to us, and quite frankly, would be able to convince VC to give us enough money to go scale up the tech. So it was really the sort of like technical market premium to the prices that are out there that are still above where you can sort of dig out the ground and burn it. But I think that was the necessary condition for us to get out of kind of the lab world.
Going like one step deeper into that, I'm curious, what were the hardest I mean, validating a TEA, it's hard. It's a like iterative process. So what brought you comfort that like this model was, solid enough to really buy into it?
I think in retrospect, it wasn't.
Yes.
But so the luxury we had is like the space has got lots of academic literature. And so what we did is we compiled that literature, and it's like, we know what it costs to do X. NREL's got studies for electrolyzers. So I think we built a reasonable first pass at, having a sense of what the cost could be. I think the second thing, which was maybe where I sort of influenced it a little bit more, is we need to at least get down to 2 or 3 risks. So are there 2 or 3 things in this 10,000 line model that are actually driving our economics? And do we understand those 2 or 3 things well? Of course, in time, another 50 things emerge and you realize you didn't know anything at the beginning, but being able to reconcile down to, we understand what the risk is, we think we can get there, and the model is compiled of reasonableness internally, not sort of what we can tell the world, but we believe that this actually could work, was the goal.
Okay, makes sense. So David and Jan, you both talked about the importance of customers and customer relationships. Can you talk a little bit more about what the process of establishing some of these early customer relationships looks like as you scale your technology? You're continuing to scale your technology, but you have to kind of validate the market at the same time before you even maybe have a product. So what does that look like? Has anything surprised you that you didn't expect going into it?
Yeah, only surprises. And I think you should hunt for those surprises. Like definitely, the more surprises you make or you come by, if you're surprised about something, it probably is true. Like that is the next truth, sort of next stage of truth. Because customers, you need to address their pain point. What is on their agenda? What's the person you're speaking to on the other side? What is their job description? What is their goals in their role? So you need to cater to them. And so we've always been we keep trying to be customer driven. It's just one of the most critical things. It informs everything we do in the company, because ultimately, as you raise money, the investors will only give you money if there is customers willing to pay for your product. And at different stages, like seed stage, okay, if some customer signaling is needed, Series A, we want to raise a Series A later this year, we need to show that customers will give us letters of intent, at least that signal that they will be off taking the product. And at Series B stage, when we actually build the factory or the unit, then we actually have to have off take, right? And again, it's all customer driven. And so, yeah, surprises were that we think everybody must want recycled plastic or recycled polyester, and no, they want to be compliant with regulation and not pay as much as they have to, or as little as they have to. So yeah, understanding that was interesting. And one thing that I think is very helpful, we found helpful, is going to conferences. So go seek out the conferences where all the customers that are in your market are going to. That is the most efficient way. Face-to-face time is invaluable, is much better than Zoom calls or emails, of course. Yeah, so going to conferences, you get bam, 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 so quick interaction with customers, and you learn so much. I always find it amazing. You come back completely mind blown, and you sit down, take all your notes, and disseminating that with the team was always really exciting. And yeah, we cherish conferences still.
No, I'd echo that. You got to go to conferences because you can just meet the people you need to talk to, and they're right there. I mean, if you try and email like someone in the C-suite at whatever company you want to talk to, I mean, they've got 35,000 unread emails. They're not getting it. But at a conference, you walk up to them, hey, I'm Dave. Like, you're right there. You got their attention, and that helps a lot. I don't remember the exact wording of the question, but it had something to do with customers. So I'm going to say for us, it looked like a lot of us who are selling B2C, right? If you're selling climate, you're probably selling B2C, which means you're working with bigger companies. And it can be really scary to kind of push them because, you know, what if they say no? You know, and then this doesn't work. Like, they haven't said yes to me. I'm not going to push them, so I'm never going to get a yes, but I'm also never going to get a no. And that kind of feels like, you know, there's still the potential that we could go somewhere. But that no can be good because then you know, like, know why. And they can tell you what's wrong and what's not working. And then you can adjust your strategy. And maybe if you have to change your product or make a little adjustment, and then you can get back on the horse and for the next customer, do a much better job.
And actually, another surprise I can maybe share is that multiple ins to the same company can also go a long way.
Yes.
I think, is that what you refer to? You get a no from one person, you get a yes from another?
That is, yeah, that's part of it as well. And also, I found with customers, like, a lot of times a no is not like a no forever. A no is like, hey, this doesn't really make sense
today.
Yeah. But like, you can come back and re-engage, and maybe it makes more sense later or with another person within the company.
So there's some similarity to the VC world, right? You get a no, no, no until it's a yes. Like, oh, wait a second, let's talk again. Happened last week with a customer. The VC will.
Garrett, do you have anything you would add in terms of, you know, SAF, it's a commodity good, but in terms of establishing like trust with the customers at this stage?
Yeah, I mean, yes, I think it's a commodity good, but like the people that buy our product are executives in airlines, and they have all the things that come with that. I think what surprised me was there is such, there was this sort of like emergence of a whole bunch of companies that were trying to do this about a decade ago. And so the airlines are pretty burned on, we've heard 1,000 stories about how you're going to take down the cost, you're going to do X, you're going to do Y. What we ended up doing, and this turned out to be smart, not, or maybe lucky, but seems smart in retrospect, is the airlines are in this complete network of their supply chain. And so you can get to the OEMs, the Boeings of the world, who have a totally different interest, and they can make those introductions for us. So we end up actually getting more success getting introduced, think like the ecosystem of our end customers, because the motivations of those secondary suppliers and that are very different. And it's not the standard, like, we've got SAF, we can get to this, we can do that. Like, they've heard all those pitches before. And then once we were in, we basically used them to dictate to us, which I was surprised that they were, to follow the surprise kind of narrative. I was surprised that they wouldn't do this, but they basically dictated to us the milestones that they wanted to see before they would give us firm offtake agreements, which is the ultimate goal. So we actually sort of crafted this round that we're closing this week or next week, it's already Friday, around those dictated terms, which was really helpful and surprising that they were willing to share that much. So.
It's really interesting. Thank you. So, you know, all three of these technologies fall under the umbrella of like deep tech, tough tech, you know, kind of requires a fair amount of capital. And so how have you thought about your capital raising strategy as you've moved through, and maybe just talk about some key decision points and, you know, dilutive versus non-dilutive. What has that looked like thus far?
Look, I think start at the end, right? What's the business model and what's the company you want to, and what's your exit look like? And then work your way kind of retrograde back from that. And I think that tells you how much capital you're going to need if everything goes well along the way, and then you can start to get into the strategy. As we thought about it, we are incredibly capital intensive as a business at the scale that we aspire to sort of build our plants. What we did was we basically went and looked for analogs that felt like the same business model with the same kind of market attributes, and then looked at how they had raised capital and essentially emulated that. We also, I think, very early went multinational in terms of capital strategy. So the non-dilutive that exists around the world for the things that we're doing is pretty deep. And if you sort of stick to one market, I think it's pretty narrow. And so I think that ended up being pretty helpful as we think about where we raise for what scale of plant in what jurisdiction, and how we sort of align that with the venture side, which is really mostly US based, has worked quite well.
Yeah, I mean, we are always incredibly grateful for the non-dilutive funding that we, for example, have available here, Mass CEC, right? We have folks here in the audience, I believe. Things like that, and NSF and SBIRs and so on. But we cannot rely on them, especially from timeline perspectives, with some disruptions that have happened recently as well. So we definitely sketch out a diluted timeline completely, and everything else is additional and is, can delay a fundraise potentially, but we don't rely on non-dilutive. And of course, fully agree with the previous comments. And in addition, we have to also build a factory of recycling clothes and textile eventually, and we cannot scale from a lab straight to that factory. So we have to have certain stages in between where we can prove out the unit operations that make the process run. And so what we found we were trying really hard to do is not to reinvent the wheel or any equipment that is already out there that can be used for our process. So rather than, in our case, we try to make it not an equipment innovation, but a chemistry innovation. And so we're utilizing toll facilities and contract manufacturers to prove out the different stages or simply service customers. And that's what we're trying to set up right now, a contract manufacturing site that is able to produce 10x at least what we can do here at the engine. And that is enough to service customers with does this actually work, to get these off takes?
Yeah, to be honest, I would just echo exactly what they just said. It's phenomenal from both you guys. So I won't add anything to that.
That's fair. Would any of the three of you, any of you can take this, all of you can take this. What advice would you have in terms of thinking about, on the dilutive side, who the right investors are to partner with as you're thinking about the type of company that you're running? How did you test that this was the right relationship as you were going into it?
I'd say it's definitely about more than money. For sure, these people are going to be, potentially on your board. They're going to be people who you work with, and you want folks who can help and are excited about helping. And you can see that during the fundraising process. If you talk to someone and they're just kind of aloof and not really paying attention, then great. But if you know someone who's actually we're going to give you, maybe even a little less money than maybe you hoped, but I'm going to connect you with this guy and this guy and this lady, and we're going to go here, and I think you can do this. That's the type of excitement that really, really drives things forward.
I fully agree with that. These people are, they say these are the people you go to bed with for a reason, which is an interesting term, but it is kind of like that. They're so close to what you do on a daily basis, and some of them might check on you weekly, which may be a good or bad thing. But yeah, you rely on these people, and they rely on you. They trust you with their money, with millions of dollars, and you execute under, a shared vision, ideally. And so, yeah, what we've found really helpful, and I think I don't know if we got lucky, but we definitely, we talked to 150 investors at least in this seed round until we found our leads, Clean Energy Ventures and Volta Circle, a family office. And we are really grateful. It's a really amazing relationship. We love these investors. They help us greatly. They make these intros that they've talked about super critical. They introduce us also now in the next raise, because they want you to succeed, ideally, right? They want you to raise the next round of funding. And so they make us intros for the next Series A investors, which is really helpful. And it's a co-lead. And so the other lead, Volta Circle, they're highly technical. So they have a very strong presence in the PET and plastics recycling space that we're in. So we've had yeah, not only financial support, but extremely valuable technical support from them, which I found always super helpful.
Yeah, I agree with that. The only thing I would add is I think, and I've made I've made so many mistakes in particularly this round on this particular front. So cautionary tale. But these are hard-won thoughts. Number one, I think about your syndicate, like the group that you want in, from almost like a metadata perspective. Like you're looking for certain things. You're looking for ability to write an extract, technical expertise, connectivity into the market that you care about, and actually try and construct it. It's never perfect, but try and construct it around those attributes, and then all the other things of like you actually have to like these people because you're going to be working with them day in, day out for years. So but I didn't do enough research up front and just started like scattershot talking to investors, as opposed to, look, I need someone that meets this set of criteria, and here's why that's important, because that actually helps with the sell, because you actually show up and you're like, here's why I'm talking to you, it's for this reason, and that lets you sort of enter into that conversation in a way that's not just like, I'm here to pitch. So
maybe for the PhD folks in the area, in the audience, when I looked for my PhD project and I selected a group and chose a professor to supervise me, I went around and interviewed them also as much as they interviewed me, really doing the vibe check. Like the VC game is very much about vibes. The VCs will invest only if the vibe is that you are the hottest commodity in the space and that everybody wants to invest in you, and you have some other options, then they will invest, like the FOMO. But likewise, you need to have good vibes when you talk to them. You need to be inspired by their thinking. And so, yeah, I want to just echo that.
If I may, one thing with when you're meeting with like a VC, it's not like that hard to talk to a VC, but it's something that you want to practice. I remember the first time I met with a VC, it was like, I mean, I just completely screwed up. You know what I mean? Like, I didn't know exactly. Like, I was like, "This is the story for the company," and they started asking these questions, and it was like, I didn't know what they cared about, and I don't know how I expected it to go, but it did not go that way, and it it would be really beneficial to even just do practice meetings with people who anyone in your network who is an investor, anyone who's like not like live trying to invest in you, just to like get a sense for the story and really nail that in before you just go live and make a fool of yourself the way that I did.
Thanks. Good advice. Okay, two last questions, quick ones for you. Well, you can take your time if you want, but one of them is just, what have you learned about you? Kind of team has come up throughout the conversation. What are some of your learnings about what makes for a successful team dynamic at this stage and what you need out of a team?
The team, so this is hard work, right? And there's changing goals often. I mean, we try to lay out a plan, and what we've, I think, done better this year than last year, for example, is not making, briefing my team, oh yeah, next week we need this, and in 1 month we need that, but really trying to lay out the plan more on a half year or a year basis and follow the OKR principle, objectives and key results, so that the company knows exactly, everybody in the company knows what are the company goals. Let's say, solving this big problem. For that, we need money. We need to fundraise. For that, we need to go with customers. For that, we need to provide them with data. So everybody knows exactly in the company what they're working on right now is immediately relevant to the company's success. And you reward your companies, your employees with shares. So you are all sharing that mission. So we're trying to make sure that everybody's really excited about the mission of the company. That motivates people, and it can likewise it can demotivate people, which has happened to us before as well. If somebody in the company thinks, everybody's working on the company mission, but I'm not really, like, my work doesn't really have anything to do with the company mission, that can be very bad. So the alignment of mission is incredibly important. At the same time, don't burn out your people. They need to come to work excited to work and not, oh shit, I have to go to work again. So create some good company culture, go for dinners and drinks with them, and give them the afternoon off if you achieved some great results, and have a good time with them as well.
That was great on leading teams. I'd say we don't have a huge team. When I do, I'm going to call you up. But I'd say in terms of co-founders, it's all about how well you can work together. And as Jan said earlier, like getting through, the hard times. And that's why I think they say coworkers are like generally the best, like people you get along with well from work perspective. Before Helix Carbon, I started a company with my then best friend. You've never heard of that company, and we're not friends anymore. But now Evan and I work together really well, and Helix is doing good things, we think. So
Just add one thing. I think this is probably going to sound like BS, but I think at the beginning it's you and a co-founder likely, and I think it was worth it for us to spend a lot of time, much more than we thought we would, defining what the values we cared about. That sounds like hokey relationship bullshit, but actually, like, we are going to be really transparent, and we are going to sort of have a value of flat org or whatever you decide, because you can then take that to prospective hires and be like, here's what we're trying to build. Here's how we're going to treat you. There will be some times where we can't tell you what's going on, but if we can, we will. You don't have to live by that, but like that sort of very, very early on, I think builds a degree of kind of trust and culture that ends up with a strong team if it's done right.
Thank you. Last question. We can just go down the line this way. What is next for your startup? What are you excited about that's coming up?
So I mentioned this, we're closing around sometime next week, and that will give us funding to go build a large multi-barrel a day plant, which is like a meaningful milestone in this space over the next 18 months. So I'm getting out of talking to investors and starting to think about like, where do we site the plant, and do we have the right facilities and things of that nature? So very excited to do that.
It's amazing. Yeah, we're maybe in a similar position. We're very excited to ramp up this toll manufacturing site that I talked about. So producing the first ever 50 kilograms of recycled polyester material. And we're looking forward to deepening the relationships we have with the supply chain partners. Speaking to the point that we had about supply chain, like understand the supply chain of your customers, work with them. So a big goal this year would be to make a first ever macrocycle garment, maybe this jacket, throw it in and get it back out. Yeah, and we're excited about the fundraise. Maybe not excited. I don't know. We'll see.
you guys you already have the thread. You already have the thread. It's incredible. It's up in the office. It's great. Yeah, but still, that'd be so cool. You throw it in, recycle it, get it back out. Oh, that'd be sick. So nice. That'd be so good. That'd be so good. We're kind of in the opposite boat of these gentlemen here, in that we closed our fundraise last year, and we had 3 goals, which we are now either executed on or about to complete the execution of, and now we are about to throw our heads down back into the fundraising ring again. So it's an exciting time. It's a fun time. It's a hopeful time. It's about to be an incredibly even more busy time, but we're looking forward to it.
Congratulations. Sounds like great progress on all fronts. Okay, so I'll open up now. If any of our audience has any questions, this is a great time to ask anything that's on your mind of these experienced founders.
Hello.
Holy camera.
I was just kind of curious, I guess, how you found it in you to like. I heard you guys all like pivoted a lot throughout your journey, and like, I guess it seems like values was really important to you. But I guess what kind of inspired you to like stay together even after having to pivot, or is it kind of a need base to kind of meet the investor for the next round?
For us, the pivots, I mean, pivots can be scary because if it's a technological pivot, you're moving away from your beloved own technology. But or if it's a market pivot, you have formed relationships with certain customers and now you're opening a new territory. So it can be scary, but I would advise, or I've always felt relatively also excited about it at the same time, because a pivot means you are going in a better direction than before, right? You make the pivot for a reason. Like, you shouldn't pivot it just for an investor. I think you should pivot for, like, if the customer needs it and if your technology previously didn't allow it. So then you should pivot. So yeah, in my mind, these tantalizing moments where shit, there's something new happening here, and we got to crank it out, and soon we'll feel, good again, I guess.
Hi, thank you. I was curious about how you guys thought about delegation at the really early stages when there's just so much to do in so many different domains all at once.
Yeah, so I'm the CEO. My co-founder is the CSO, which means I get all the terrible work like taxes and payroll and accounting and legal, and he gets all the science stuff. But no, I mean, honestly, like we just like sort of in the early days, it's really just a question of like, there's more than you can do that needs to get done. Just rank order it and do what you can, and you just share the burden as much as you can. I think as you mature, we're now at 14 people, about to like grow to 20 over the course of the next 6 months. I think we actually have to like draw an org chart that's got like defined roles and people actually know what they're doing. You move through phases, but in the beginning, it's just, a free for all.
I definitely agree with that. And I'd say a lot of it is you develop trust with the people you work with, especially your co-founder. I know like when Evan and I were first starting out, it was like, well, both of us are going to meet with every investor. Both of us are going to meet with because we both we both have to be there. And now over time, it's like, you own that, like, I trust what you're going to tell these people. He trusts what I'm going to tell people. At least I think he trusts it. He lets me do it. And you start to realize like, oh, this works a lot better when we've split the responsibilities up and we trust each other and we can communicate to each other when, something doesn't go the way we expect it to, and we can communicate through either bad or good news.
Fully agree. And I think it goes then into this whole team development aspect. As founders, you might tend to want to micromanage or keep your tabs on everything that's going on in the company. But raising a team of the employees you hire, making them into leaders of projects or customer relationships is a really powerful thing that, every time you don't do something and they can do it for you, the company moves faster. So that was one of the learnings we had as well.
Any other questions?
Hey, I think you mentioned about setting aside the time to, talk about the values or spend more time on it than you think you need to. I think something I struggle with is kind of what you were saying, like you always have the list and you're kind of chipping away on what's top of mind. Do you guys have good strategies or tactics to actually hold yourself accountable for setting aside that time, or any tips on cadence and things like that with your founding team?
We do a co-founder, so we do like a co-founder sync every week generally, which is more like updates with the company and what's going on. And then we do like a co-founder like sync every month where we go out away from the company, we sit down, we have coffee, and we're like, what do you think? What's your crazy idea? What do you think about this? Like no holds barred. And that really helps us. A lot of times we end up coming out of that like way more aligned on things, and it's really helpful to have that time. So monthly, just like an hour.
Yeah, we're pretty similar. I think the values thing, like that was just once, like we spent 2 days, like what do we actually care about and what are we going to hold each other accountable to? So like that was like an early, let's just make sure that we are aligned, because we come from, he has like a science research PhD background. I was like MBA and bullshit business stuff for 20 years. So
yeah, it's real. It's real.
Very, very different backgrounds. And so we just wanted, so I think that's a one-time thing. Exactly what was just said in terms of, weekly, monthly, deeper conversations. And those are just like really unstructured to go through that list of, outstanding items across a set of categories.
Yeah. I fully agree with the founder meetup, and keep like have space and time where you can think openly, but also with employees, make time to actually meet with them one-on-one, maybe more frequently than you would think would be necessary. That really helped us understand more what's going on in the heads of our employees to make them more, happy, and when they're more happy, they're more effective. So that was interesting for us that we implemented, and I think it goes really well. The other thing is the cultural pillars. I think we learned that in Delta V. We said we will have roughly 5 pillars of cultural pillars in the company. 2 of them on the outside are set by the founders,
And the center three pillars will be defined by the employees in different stages of the company. So every sort of year, basically, we have the employees by themselves sit down without us and think, what is the culture of our company? What is another pillar of the culture of the company that we want to place in there? And that this cultural pillar work and what they mean sits in our employee handbook. So every new employee reads that handbook and is sort of onboarded into getting a gist of what the mindset of the company is. Of course, they should learn that in the interview process as well. Hopefully good vibes, but they will read about it too.
I would say kind of on that, it kind of falls into like a sector too. So are you all familiar with like tasks, the urgency and the importance and breaking that up? For those of you who aren't, tasks are urgent or they're not, and they're important or they're not. And generally if things are urgent and important, you do them now. If they are not urgent and not important, you don't ever do them. But the things that get overlooked are the things that are not urgent, but they are very important. And that's where you make a lot of money being able to knock some of those out. So one thing that has helped us a lot is like we block, at least I do, like an hour and a half every week. And I'm like, that is my sector 2 time. Like, I'm not going to schedule any meetings in that time. And in that time, I'm going to focus on one of these sector 2 tasks. And that would be one, like meeting with your co-founder and having that conversation would be a good example of that.
Great, thank you so much. We have time for like one quick question if anyone has any. Otherwise, we'll go ahead and we'll move into the coffee break. And everyone will come back at 3:45 for us to announce the finalists. Great. Okay, let's continue. Thank you. Thank you so much.
I can get all of the founders on the stage for anything and group photos of all of the semi-finals. Come on up, founders. Yeah.
Nice.
Yeah, so I'm gonna call roll fast. Cosine. Here. Ignition. Interlinked. Iron Lattice. Lidge 3D. Mineralize. Osyta. Cartel. Shinra. Terra. Terra went to the airport. Okay. Oh, look. Do what? George, CP, y'all go find it. Not one for everything. Be careful. One second. I got it. Relax. No, I'll give you a signal when I'm ready. So relax. Don't hold your small bit off. Don't worry, that shot. Just careful my question. All right, now I'm ready for the real deal. Okay, right here. 3, 2, 1. Oh. 3, 1. All right, the funny one is turning the moon. Okay, 3, 2, 1. All right, thank you very much. Thanks, guys. All right, everyone, I think we're ready to now. Like my idea.
So should the sponsors come up and? give
We're
the
gonna do
check?
all of that later. Let's do the announcement.
No, I know, just to
Oh,
give the
you
check,
want
that was
the-
my question, but no.
I don't think so. No,
Okay,
I think
okay, but we'll do
we
pictures.
can just do that. Yeah,
Yeah,
we'll do pictures.
Okay, cool.
I think it's like, okay. Is this right?
Let's do that as one of the first picks.
Which one do you want to be the opening slide?
Yeah, the top one.
This one?
Yeah, thank
Okay,
you.
where's the, let's go ahead and this up here so we can leave this.
At the end. Okay, cool. Where's Michelle?
Michelle go? Did Michelle get shot?
No, she's just getting people from that side.
Oh.
Reboot the screens.
Why is it like that?
You exit, you can see things.
Never mind. Can you mute again?
Can we copy paste this into?
Yes. Should be able to work fine. That's like wildly unhard. No, we shouldn't have gathered everyone already. This is embarrassing.
Thanks. Okay, go ahead.
Wait, stop the PowerPoint. Just stop
Yeah,
sharing because
there
that's
we
usually what ends it. And then just share the Google Slides and try that. Then I'll say words. Let's finish this out. Okay. Hmm? Hi, everyone. Welcome back. Thank you so much for being with us this full day. It's a long day, but we were really excited to hear all of your pitches, and you all did a really excellent job. It's been really interesting to hear what you're working on and to have such a different diversity of solutions and issues being tackled. And so last thank you again to our sponsors. Seriously, without you guys, we couldn't do this prize. You sponsor the prize money, you come back year after year, so thank you very much. And without further ado, we had 10 semifinalists come with us today. And we're really pleased to announce the 4 semifinalists that will be moving on to join us on April 17th at the Boston Grand Final, which will take place at Greentown Labs. So without further ado, the 4 startups that will be joining us are Cosine, Interlinked, Mineralize, and Terra Compliance. Congratulations. And lastly, we have one semifinalist winner who will be going home with $5,000, as well as the opportunity to come back to compete for the $100,000 in April. So congratulations to the winner of our Boston semifinals, Cosine. You can come on up. Thank you all so much, and big thank you again to our judges who spent a lot of time thinking about this and with us today. So we're gonna go and circle through some photos. So startups, everyone stick around, but this concludes our official event. So thank you all. If we could have the 4, okay. If we could have the 4 startups who are advancing to the grand final come up, that would be great. Thank you to start. Thank you. And now if we could have Cosine and if we could have our sponsors go ahead and come up, we would love to have you all have a picture with the semifinalist winner. You want to grab your shot? And then if we could have our judging team come up and take a picture with the winner as well. Thank you.
High expectations.
Thank you. And last but not least, could we have our CP organizing team come up and take a picture? Thank you. You're good. Thank you. Full team. Alejandro, can you come in for an honorary one? Good idea. Thank you. Thank you. Thank you, everyone. Feel free to mingle outside. We have cookies and coffee and whatnot. Please chat.